Hello. I all right. I'm going to work on cast one more time. What do we have right now? Let's see. So I was doing the context inference stuff. Typo in title unfollowed? What do you mean? Oh, there is actually a typo, no way. Sorry. I didn't use ChatGPT to write the title. I wrote it myself, so typos can happen, you know. You know. Hello. How are you doing? So I did the inference last time for the context, but I think it's very far from being perfect. What's happening? Is it compiling right now? I think it is compiling. Maybe I could remove the quiet from here. Yeah, actually, let's remove the quiet from there. There you go. So we have a function that prints hello world, right? Is this. So function is a function with the context, which requires us to know how to write. Yeah. So before this was happening, we were only having in the type inference system the equalities, basically, which made it a lot easier. With the inference of the contexts, we actually now have like subtyping, and it's far from perfect right now. So previously we had like variables, like variable A, variable B, variable C, right? A, B, C. So these are the type variables, right? And we basically said that this A is the same as B. So what happened is that those two variables, in this case, they are now considered to be the single one. We just merge the variables into a single variable when we have the equality constraint. When we know that two things must be the same type, right? But when we have the subtyping, like in the like in the context stuff, that means that like one variable can be like a subtype of the other variable, and that variable can be a subtype of another variable, and then we can have like any sort of a graph technically in this thing, right? So when I see a constraint like that, so like previously basically it was bidirectional, and now it is like the only one direction. So when we have a thing where one thing is subtype of the other, we don't really know. Like it doesn't mean that they are equal. I cannot treat them as a single thing anymore. So what this leads to is that when I discover some information about this variable in the bottom, for example, right? Like this over here. Like if these are all the context variables, right? For inference of the context system. I know that like let's say that these are like functions and their contexts, right? I guess if this function requires IO, it means that this function requires IO and this function requires IO and all of these functions require IO, right? So like previously since I was treating all of them as one, in order to know what the variable b is actually, I just needed to know the value of the whole thing that I had merged, right? So the every variable was pointing just to the single thing, which is the which is holding the actual information. But in this case, we cannot do that anymore. And what's happening right now is that I'm actually pushing the information through this graph, one by one, right? So if the graph grows, it becomes big, then it will take a long time to actually push the information, right? So maybe there is some algorithm that we can use. I didn't really think about it too much though. There are right now two cases where we want subtyping. One of them is the context system, another one is the lifetime stuff, which I don't have right now, but we will. So in Rust, there are such things too. So in Rust there is subtyping, but it basically is only about lifetimes. The way they do this is that they so when they know that two things must one thing must be a subtype of another thing, when you force two types to be a subtype, like T is a subtype of I32, we can often convert those to equality constraints. So like there is no actually subtypes if there is no lifetimes in Rust, almost always. So in this case, it's the same as T is equal to I32, right? However, in some cases, we might have to be more careful. For example, when regions are involved, regions are lifetimes. If you have T is a subtype of A I32, so this means that T is actually some lifetime B I32, where B is a subtype of A subregion, right? This will result in a region constraint, BA. I'm not yet sure what to do today. Let me figure it out. I was thinking of working on actually like some sort of new inference engine, which has the subtyping, but I did not think about it too much. Maybe we can see how other people do it. Type inference with subtyping. Type inference and subtype polymorphism don't mix well. There has been recent work, algebraic subtyping, showing the two can mix well. Oh no, it's going to be a PDF, isn't it? The simple essence, yes, of the algebraic subtyping. Functional Perl. ML sub extends traditional Hindley-Milner type inference with subtyping while preserving compact principal types. An exciting new development. However, its specification in terms of B unification is difficult to understand, relying on the new concepts of B substitution and polar types. Let me just write down here. Wait, can I make them afterwards? Isn't that what it's supposed to do? Set wrap. Text width. Is that what I should do? Huh. Fine, I'll do it manually. Whatever. We presented an experimental evaluation of simple sub against ML sub on a million randomly generated well-scoped expression, showing that the two systems agree. The mutable automaton-based implementation of ML sub is quite far from algebraic specification, leaving a lot of space for errors. In fact, our evaluation uncovered several bugs in it. Alright, I don't know what ML sub is. A specific, so ML is the programming language, and ML sub is ML with subtypes. The ML family of languages, which encompasses standard ML, OCaml, and Haskell, has been designed as around a powerful global approach to type inference, rooted in the work of Hindley-Milner. In this approach, the type system is designed to be simple enough that types can be unambiguously inferred from terms without any help of any type annotations. That is, for any well-typed annotated term, it is always possible to infer principal type, which subsumes all other types that can be assigned to this term. For instance, the term lambda XX can be assigned types bool and int, but both of these are subsumed by the polymorphic type plural A into A, also written as this, which is the principal type of this term. The Hindley-Milner type inference approach contrasts with more restricted local approaches to type inference found in Scala, C# and Idris. Wait, C# has that? I don't remember. On the flip side, abandoning the principal type property allows these type systems to be more expressive and to support features like object orientation and dependent types. Wait a second. Oh, yeah. This approach contrasts with the local approaches. Yes. Like, this is one approach and this is the other approach. So Idris doesn't have Hindley-Milner, actually. I thought Idris had the same thing as Haskell. I never tried it, though. In Idris, type inference is undecidable in general. An implementation of algorithm W in Idris. Justified type inference. An implementation of compositional type inference. Even ML languages like OCaml and Haskell have adopted type system features which, when used, break the principal type property. Okay, I mean, principal type property. What they say here. What is the principal type property? I have no idea. But basically, we don't really like say that we should unambiguously be able to infer things without any type annotations. We just want them to be a small amount of type annotations as possible, right? Subtyping is an expressive approach allowing types to be structured into hierarchies, usually a subtyping lattice, with the property that types can be refined and widened implicitly following the hierarchy. This lets one express the fact that some types are more precise than others, but still have a compatible runtime representation, so that no coercion between them are needed. For instance, in a system where the type nat is a subtype of int, natural number, one can transparently use a natural list in place of an integer list without having to apply a coercion function, all the elements. Subtyping can be emulated using somewhat-heavy type system machinery with both OCaml, which both OCaml and Haskell do to some extent. But first-class support for subtyping gives the benefits of simpler type signatures and better type inference. For a long time, it was widely believed that implicit subtyping got in the way of satisfactory global type inference. MLSub was introduced as an ML-style type system supporting subtyping, polymorphism, and global type inference while still producing compact principal types. Compact refers to the fact that the inferred types are relatively simple type expressions. This was achieved by carefully designing the semantics of the subtyping lattice using the algebra-first approach, also referred to as algebraic subtyping. However, the specification of MLSub's type inference algorithm is the unification. It's difficult to understand for experts and non-experts alike. On the surface, it looks like more complicated than the algorithm W traditionally used for the Hindley-Milner type systems, requiring additional concepts such as B-substitution, polar types, and advanced notions from abstract algebra. Although its elegant presentation will appeal to mathematically minded researchers, experience has shown that grasping and understanding of the approach complete enough to re-implement the algorithm requires reading the thesis in full, and sometimes more. Thankfully, it turns out that the essence of the algebraic subtyping can be captured by a much simpler algorithm, simple sub, which is also more efficient than B-unification. Nice. So we have something that is simple, and we don't require a PhD to understand. Is that correct? Let us first describe MLSub and the algebraic subtyping philosophy that underlines its design. There are at least three major schools of thought on formalizing subtyping. Syntactic approaches use direct specifications for the subtyping, closely following the syntax of types. Semantic approaches view types as sets of values which inherit them and define the subtyping relationship as a set inclusion between these sets. Algebraic approach define types as abstract elements of a distributive lattice. What even is this word? What does this mean? Whose algebraic properties are carefully chosen to yield good properties, such as extensibility and principal types. Syntactic approaches somehow pay for their simplicity by forcing type system designers to consider the consequences and interactions of all their inference rules, and manually verify that they result in subtyping relationship with the desired algebraic properties. The semantic approach is probably the most intuitive and is also very powerful. However, it suffers from difficulties related to polymorphism. Dillon argues that algebra, not syntax, should come first in order to guarantee from the start that the type systems are well behaved, as opposed to ensuring it is a sort of an afterthought. In particular, the concept of extensibility of type systems, the idea being that existing programs should remain well typed when new type forms are added. While the practical usefulness of this notion in extensibility is unclear, the general approach of making subtyping lattice distributive does help simplify types aggressively and construct algorithms for checking some assumption effectively. Should I even read this? I cannot understand almost. I mean, I understand something. And then there is going to be this. Informal semantic of types, expressiveness, essence of type inference. ML sub is all about supporting unions and intersections in the type language, forming a distributive lattice. A new algorithm called B unification as an alternative to traditional unification. So there is B unification, DMAC DC. Hello, hello. Separating the syntax of types between positive and negative types. However, we argue that this is not the most helpful way of understanding the process at work at this type inference algorithm. Instead, we argue that the essence of the approach is making the semantics of types simple enough that all inferred subtyping constraints. All inferred. Okay, this is one. This is the old one, and this is the better one. Making the semantics of type simple enough that all inferred subtyping constraints can be reduced to constraints on type variables, which can be recorded efficiently. For instance, using mutation, as done in this paper and in MLSub's actual implementation. All inferred subtyping constraints. So like we have subtyping constraints, okay. We can reduce them to constraints on type variables. So a subtyping constraint is basically like a constraint between two variables. Are they saying that we can, instead of having the constraint that is involving two variables, we can reduce it to constrain on variables separately? Is that what it means? I'm not sure. Using intersection, union, and recursive types to express compact type signatures where type variables are indirectly constrained, avoiding the need for separate constraint specification. The simple subtype inference algorithm. We start with the internal Scala syntax used in the algorithm. Case term. Why do they like shortening the words this much? This is a literal, this is a variable, this is the lambda, this is application, like function application, right? This is a record, this is a cell selector for a field. Okay, at least they have comments. I mean, I can kind of guess what this means, but like, why do they like shortening the things so much? Sure. So this is the language that for which they try to implement the inference. Is that right? Simple type. Simple type is either a variable, a primitive, a function, or a record. So these are all the types that they have. Or I'm doing right now something a little bit different. A type variable for me right now is not really a part of the type enum, but I mean, okay. I understand. Type syntax, we have variable state. So a variable state has lower bounds and upper bounds. Okay. Interesting. Okay, so we have lower bounds and upper bounds, which are types, which potentially can be also variables. The state of a type variable is simply given by all the bounds that are recorded for it. Okay. So when we say that A is a subtype of B, we basically introduce the B as an upper bound of A. Is that it? Is that all that we need? When we have a subtype constraint, all we need to do in order to perform type inference now is to find all subtyping constraints entailed by a given program and to propagate these constraints until they reach type variables, which we can constrain by mutating their recorded bounds. But when you say propagating these constraints, like, I mean, that's what I'm doing, kind of, right? I'm going, like, whenever I know something, I'm propagating that something. Right? Basic type inference, typing. The core function for type inference is type term. Okay, whatever. Okay, maybe I can read the code. The Scala code is like easier to read than those math things that they had earlier. Context, map string, simple type. Constraint, left-hand side or right-hand side. So constraint means that left-hand side is like a subtype of a right-hand side. I'm assuming is what they're trying to do here. You still need dark mode for this page is protected by the browser, so the PDFs don't work. Can I wait, this page is protected by the browser? Enable for all sides. So you cannot do the dark reader on the PDFs? Right. I mean, it doesn't really hurt me that much. It's day out right now, so yeah. I mean, one more reason to not read the PDFs, I guess. You cannot invert the colors so easily. Inspector. Inspect. Body. CSS invert colors. There you go. You like this? I don't need any like dark readers extensions for this to work. We can do everything we need with the CSS. Can I hide this sidebar? I don't like this being there. Toggle sidebar. There you go. Can I toggle this thing at the top too? Probably not. There's also a browser extension limitation that's hard to circumvent, because browsers protect the PDFs and the extensions don't work on PDFs, right? So like none of the extensions work here. Yeah, okay, that makes sense. I mean, maybe there is like something. Firefox PDF Dark Reader. Sorry for blinding you again. I'm not actually using Dark Reader, even though I have it installed. There is a hidden setting to change the background and toolbar areas to dark mode, but the document will still follow the author's colors. PDF reader, dark mode options. Did you type this into the console? That's literally what I did. Alright, whatever. A fresh variable is a variable where we have no lower bounds, no upper bounds. Okay, that makes sense. Remember that variable state is a class and not case class, also called data class. Yeah, whatever. This means that each variable instance is unique and distinct from other instances. It means that it's like it's passed by reference automatically, right? Whatever. But we have extended the next we can start writing the core of the basic type inference algorithm. Type term implicit context simple type is term match which primitive int type term. Okay, makes sense. Makes sense. Record. Okay, yes, that makes sense. This is basically like going from syntax of the type annotation to the actual type. So we can specify literals. So like these are just integer literals. Integer literals are int. If we have variable names, then we get the current type variable for the name, right? So this must be existing in the scope, or if it's a record, then it's then the type of a record is the record type, and then we just go recursively. That makes sense. We do the same thing. We have a lambda, then the type of a lambda is a function, parameter, and that stuff, right? Parameter is a fresh variable. Sure. Application. So okay, here for type applications, we similarly introduce a fresh variable standing for the result type, right? So when we apply a function a with argument a function f with argument a, we say that the result is a variable, and then we say that the function must be a function from type of a to this result type. We literally do the same. So constraint right now, is it? Is this also like with subtyping already? So f must be a supertype of a function, right? So f should be coercible to a function from A to result. That's what it means, right? No. F is a subtype of a function, right? That, well, yeah, because then it will be coercible. It's a subtype, not a super. Yeah, and this is a supertype here. Can you post link in chat plus in video description? What do you mean? A link in chat to what? To this? What I'm reading? Sure. I just found some random thing. I was thinking of like coming up with my own stuff, which I probably will anyway. Right now they do the same thing as I'm already doing anyway. The only thing is that I'm constraining the types so that they are like equal. So f must be equal to the function type. But I think this is just like subtype relationship, right? So far it's the same thing. I'm not sure what is in video description though. Oh, you mean like put the link over here? I don't know. It'll be like kind of hard for you to, but I guess not impossible. Stream archive? What do you mean stream archive? I don't understand what you're asking for. As one can observe, the basic ML subtype inference algorithm is so far quite similar to the traditional algorithm W for the HM style type inference. So this means that what I have right now in cast is the traditional algorithm W, I think, because that's literally what I'm doing. Don't you upload your VODs to the YouTube? Okay, so you want me to put it into the description of the VOD? Okay, that's a lot of work. But maybe if I remember. It's not going to be the only thing that I do today, right? Reading through this. I'm already half through. Alright, constraining. The first thing to diverge from algorithm W is the handling of constraints. First, know that the type variable bounds, which are updated using mutation, may very well begin to form cycles as type inference progresses. Yes. We have to account for this by using a cache parameter, initially empty, which remembers all the type comparisons that have been or are being made. Yeah, we actually had this problem when I did it for the... yeah, because like in the recursive function, in order to not like go in the infinite loop, we did this. Makes sense, yes. I thought that like if we have a loop though in the inference, it means that those variables are actually exactly the same. So I thought similar in like in the normal algorithm, you could like replace all of those variables that form a loop into a single variable. I'm not sure if they are going to be doing that here. So we have to account for this by using a cache parameter initially empty, which remembers all the type comparisons that have been or are being made. This not only prevents us from falling into the infinite recursion, but also avoids repeating identical work. For example, solving some of these sub-constraints more than once, which is important to avoid making the algorithm exponential in complexity. The next step is to match each possible pair of basic types. Each possible pair of basic types. The next step is to match each possible pair of basic types, which can be constrained successfully, and propagate the constraints accordingly. Hold on a second. Constraint, left-hand side, right-hand side. If cache contains a left-hand side, right-hand side, then we don't do anything. Okay. Makes sense. So every constraint is only being added once. But this is a type. What do you mean cache contains? Here, like, this is not obvious to me. Like, if it's a type variable, I guess in this case it's treated differently from a different type variable, even if those type variables are the same thing, for the sake of the cache here, I would assume. All right, probably. Left hand side, right hand side, match. Oh, okay, so we see what is left hand side, what is right hand side. If these are both primitives, then the primitive types must be exactly equal, because primitive types don't have subtype relationships, I guess. In this specific example. If you have a function and you have another function, so for this function to be a subtype of this, interesting, they are like in the opposite directions here. So the function argument of the second function is a subtype of the argument of the first function. Why is this inversed? Function types, because like contravariant, right? Yeah. I mean, yeah, it makes sense, kind of, if you think about it. Function types are constrained according to the usual contra and covariance of parameter and result types, and record types according to the usual width and depth subtyping. Missing field. I wonder if the records, like, so over here they are saying that for each field in the thing that we must be a subtype of, the field must be present in the left-hand side, but not the other way around, which means that we have the subtype relationship on records where we like similar to TypeScript, I guess, right? That's what the width subtyping is. So, and depth subtyping is like the subtyping of the fields themselves. All right, the case for type variables appearing on the left and right hand side is interesting, as this is when we finally mutate the bounds of variables. The case for type variables appearing on the left and right hand side. Yeah, so like if these are both variables, no, I mean if so if the left hand side is a variable, upper bound is a right hand side. So we add right hand side to the upper bound. And we constrain each of the lower bounds by the right hand side again. Okay. Why don't we constrain all of the existing upper bounds? And this is like the other way around. Okay, hold on. I need to understand what this means. I think this makes sense to me, actually. Like, if you skip some of the, like, ugly myth stuff, it's actually easy, this paper, with the Scala code. Know that there is something deeply non-trivial happening here. We installed new upper bound right-hand side before recursing into the left-hand side lower bounds. This turns out to be intentional. Without it, recursive constraining calls would get back to left-hand side, would miss the new. Without it, recursive calls would miss the new upper bound, failing to constrain it. Oh, I mean, I mean, yeah, I understand. So like, yeah. I understand. This. So one thing that they don't have a case for here is when both left-hand side and right-hand side is both variables, right? In case both left-hand side and right-hand side are variables, we are going to get into this case. We're going to install the upper bound to the left-hand side instead of like technically both of these should be equivalent. Is both of these equivalent? So we either install an upper bound on the left-hand side to be a right-hand side, or we install a lower bound on the right-hand side to be a left-hand side. These are the same, right? I mean, yeah, I guess one of them is enough, indeed. I agree. I agree with that. One of them should be enough. I would write this code a little bit differently. So, like, I mean, yeah. But, yeah, sure. Okay. I understand this so far. So we have a bunch of upper and lower bounds in the end. Lower bounds. Upper bounds. Okay, so like so the reason why we are not updating each of the upper bounds is because we have a new upper bound, so it doesn't matter, right? In the end, I'm assuming we need to somehow merge all of the upper bounds and merge all of the lower bounds, and like those are the actual bounds of our type, like user-facing type representation. In this subsection, we store the core. Okay. Where did union, intersection, top, bottom, and recursive types go? It turns out these are not really core to the type inference approach and are more like emergent properties of the pretty printing and simplification. They only come up once we try to display friendly type representation to users. Yes. So, like, in our internal representation, we have a bunch of constraints. Lower and upper bounds. Containing time variables indirectly. Remember that when we have been constraining type variables, that type variable constraints are not part of the syntax. It's supposed to output. The trick is to indirectly encode these constraints through the use of union and intersection types. Targeted type syntax. In order to produce user-friendly representation, we target the type syntax tree presented here. Union, intersection, function type, record type, recursion type. Whatever, type coalescing algorithm. In order to produce immutable type variables from our inferred simple type internal representation, we need to go through a process to refer as type coalescing. which goal is to replace the positive occurrence of type variables with a union of their lower bounds and their negative occurrences with an intersection of the upper bounds. Hold on a second. Why is the lower bound a union? So yeah, so because so like yeah, the union is the same as like the maximum operation, right? And intersection is like the minimum. So we need the minimum of the upper bounds and maximum of the lower bounds. That's why we have the union here and intersection there. Okay, makes sense. We define polar variable, something, something, something. Okay, I think I understand everything. Okay, so the core, all I needed from this paper, like they write so much here, but all I needed here as a hint to what I need to do is to have the internal representation of the type. So here is what we have right now, right? We know that this is like the inferred type, right? These are all the different types that we have, right? Units, booleans, ints, lists, tuples, functions, right? Then we also have another variant, which is the inference variable. I have it like outside of the type shape enum, right? But when we have our inference algorithm, so right now our inference algorithm just says that we either know the value of the type or we don't know the value of the type. But instead of doing this, we should know all of the lower and upper bounds of what the type can be, because now the type can be a range of types when we have subtyping. So we have this range, and instead of having just a single lower bound and a single upper bound, we have multiple of those. Yeah. Okay. Can we not just like store a single lower bound though? Like, what will break in this algorithm? If instead of storing a list of lower bounds, right? Instead of saying a list of lower bounds, can I not have a lower bound to be just a simple type? And every type I add something to the lower bound, like I need to like increase the lower bound, right? Potentially. So I need to have a maximum of both lower bounds if I have two of them, right? Which is a union of two types. So every type I do a new bound, shouldn't I just do a union? Like, why do I do the union and the intersection of the upper bounds only when we try to show it to the user? Why don't use it during the inference? Why not? So in our case, for example, right, we infer the effect system, the context stuff, right? So it basically means, right, if I have over here a function that prints hello world, right? Here is the function definition, right? It's a function that requires their ability to write and potentially something else. So technically, and yeah, so there you go. We have a union here, right? We have a union because the context of this function is at least being able to write, right? So this, when I use some operation inside of a function, I introduce a lower bound. That makes sense. lower bounds and upper bounds, and like the same stuff would be for lifetimes, kind of. So like, so lower bound is like a lower bounds would be like when the when something is still used, like for region inference, I guess, right? Lower bound is when the variable is still being used. Upper bounds is when we need it not to be used already. In Rust, we only have the lower bounds, though. In Rust inference, we only have like this, and then the region constraints only solved at the very end of type checking, once all other constraints are known and all other abrogation has been proven. There are two ways to solve the constraints right now, lexical and non-lexical. Eventually there will be only one. There is also a leak check. To solve lexical region constraints, you invoke this. The NLL non-lexical lifetime solver does things differently. It uses canonical queries. It extracts all the outleaves constraints. Down. Lexical region resolution is done by initially assigning each region variable to an empty value. We then process each outlet's constraint repeatedly, growing region variables until a fixed point is reached. This sounds very similar. This is done at the very end of the type checking in Rust. I wonder if we can do the lifetime inference in parallel with the type checking, though. So what would break? Maybe we can have some examples. Where this would break. So I think what might break is that if I have a thing like so, so these are my two lower bounds of this thing, right? Well, I mean, I guess the problem is that I don't really have the option to do lower, to do the unions. Maybe that's the problem. Like, how do I even unite the things if they are just type variables, right? Because the union of multiple variables is just like, like, I don't know, it's just, we cannot simplify it, basically. So we always have it stored as a list because we don't know much about these yet. I think that's the problem. So we can only do that in the very end. Let's see how they do it again. So so for user representation, the type coalescing algorithm. In order to produce immutable data, immutable type values from our inferred simple type and representation, we need to go through the coalescing. We define polar variable type synonym which associates a type variable state with a polarity. Type variable state with polarity. What? Polar variable. The algorithm starts by initializing an empty mutable map called recursive, whose goal is to remember which type variables refer to themselves through their bounds, assigning them a fresh type variable, which will be used when constructing the corresponding recursive type value. Polar variable. True means positive. What does a positive mean, though? Hello? The variable state boolean keys of the recursive map include the polarity in the right hand side. Make sure we produce only polar recursive types. Those whose variables occurs with the same polarity as the types themselves. This turns to out necessary for principality. Now it is fine a worker function go, which calls itself recursively in a straightforward manner, but makes sure to keep track of all of the type variables which are currently being coalesced, and to keep track of the current polarity, whether we are coalescing a positive or a negative type position. Alright, maybe I can understand from this code what a positive or negative means. Like it's based on the bound? Or what? Polar boolean. In process set of the variables is a type. So if it's a primitive, then it's just a primitive. If it's a function, then it's a function where we just recursively do this. This over here inverses the polarity of the return type. No, it inverses the polarity of the argument. Okay. Makes sense. It's similar to how we were because of the contravariance, right? So the interesting state case is the following. In the code below, versus unique name is an attribute defined in variables vs dot unique name. Okay. What's a vs? Variable. Okay, of course. Because it's a variable state, that's why it's vs. Okay. If it's a variable, then variable state polarity is vs polar. If what is this arrow? What is this arrow? This is Scala, right? What does this mean? What does an arrow mean in Scala? Scala. What does the single right arrow mean for collections in Scala? This is like contained in, or what? What is this? List string B. This isn't defined specifically on collection, it's defined on any via the implicit class arrow so you can see the definition in predef.scala. It is alternative single for creating a tuple. 1, 2 is okay. It's just a tuple. Why do you what? Why do you need some such thing then? Okay. Why do you need an arrow for creating tuples? Huh? Is how you end up with Java syntax for clowns? I mean, why is like I would expect it to be like a different thing than a tuple. That's why they need a special syntax, but it's literally the same thing. Okay, so this is just a tuple. VS and polar. So like the variable state and its polarity. Both of these. And this is what we, yeah, because these are the tuples and which we cache. Hello, Zaka Zaka, by the way. Syntax for clowns. So hot today. So if it contains, then it is a recursive. Definition. Yeah. So like so that the visual representation of a type is not infinite. We use recursion. Yeah, I have the same thing right now. Actually, we say here recursive, right? Even although this is not really true. The reason this is a recursive because the right returns a unit, and unit has already been used before. That's why this is shown as a recursive, although it's not really any recursive type. Yeah, I could improve that too. Yo, Spike is here. Yo, hi. So it's a variable that has not been processed yet. Then we know the bounds. If polar, then lower bounds. Otherwise, the upper bounds. Okay, I understand. It depends what we want to show. I got your language independently recommended to me. How? Had a look at the website. Who recommended it to you? It's not even like remotely close to being. I mean, it's kind of usable, I guess, but not really. Where did you find it? Bound types. He searches the net of new languages from Brazil. He's obsessed with them. Right. Nice. I wouldn't say I am obsessed, but like I'm also interested in just I'm just interested in a good language. And there is no a good language, so we need to create our own good language. I know where like the Eduardo from, the guy on, there's like another guy on Twitch who's making the Taika language. I'm assuming that you know about that language too, then, about the Taika language. I think I'm not sure much, but it's like a different approach. But I think our goals are kind of similar. One of the biggest differences in my language versus Tika language is that they try he wants to do like a linear type system instead of, and not have any mutation in the language. So you can like, so technically, as far as I understand it, you can have like a fast, efficiently compiled program without mutation if you have linear types. All things that I saw, this language is the closest to the language I would want to use. All right. Is there anything that you do not like? Is there anything that you don't like about what you saw on the website? My allows for a lot of modification. What do you mean modification? Like extensibility, I guess, of the syntax is. I mean, right now it's only the syntax that's extensible. I think that we want to have extensibility in like other places too, though. Yeah, but it's already like pretty powerful with the macros. Very early to tell for now. I think one of the reasons I can see a bunch of people not liking the language is the same reason why people don't like Rust. I do intend to have a borrow checker, which is based on Rust's borrow checker. A little bit different, supposed to like accept more code, but yeah. If it's very extensible and there's anything, isn't anything to dislike, right? Well, I mean, it's not like you like for example, can you change the inference algorithm? No, you cannot change the inference algorithm. Not right now, at least. I can think about how to make you to be able to hook into the type inference, because we have like the comp time, right? I can technically have the ability to hook into the type inference and write your own like things somehow there, but right now I'm not really thinking about it. The only extensibility right now is in the syntax and like the macro system, I guess. Which makes it like as like it's like basically like a Lisp without a Lisp syntax. That sounds like it would make a good language for declarative config. What did you what did you mean by that? I don't remember what I was talking then. For declarative config, you think cast can be used for declarative configuration? I was thinking about that, but like not too much. I want to be used for everything. Yeah, if I can replace Nix with cast, would be nice too. It requires some form of I think like for good declarative language, we do need like some laziness, right? Like in Nix, like in Haskell, in order to recursively refer to something. I mean, I kind of have it right now, but yeah. All right. Anyway, I'm currently researching the subtyping because subtyping is big. Subtyping is good. I need to have subtyping. Right now, I don't have subtyping. My inference only allows for like equalities of types. We need subtyping for the algebraic effect system, which is the context system, and for the lifetimes. And maybe for like structural subtype. Is that what it's called? Structural subtyping? Structural type system? Like, you know how, like in TypeScript, where you can just use like an anonymous struct and assign it to like a named struct, kind of. I think that's what it's called. Daniel Pancake. Hello, hello. Indeed, with extensible syntax, you have a very adaptable language that can function as a DSL. Yes. It's important for DSLs. Ayushman, India. Hello, hello. Yo, what up? While operating seamlessly with modules that are well-defined behaviors, templating config files is a DSL, but still the same language as the business logic behind the builders and such. Yeah. Yeah, gradient have the same language everywhere. Yeah. So out of the languages with with the same feature, there is Lean 4. Although, like, I don't know a lot of people who are using Lean 4. They have the syntax. Where's the website? Over here. They also have the same thing, where you can construct your own syntax somewhere. Notations and macros. I think it's literally the same system. The extensible parser. Macros, elaborator, notations. Custom operators is like the simplest example of a custom notation, I guess. Yeah. There is also a language that's called Seed 7 that also has extensible syntax. And then there's obviously the Lisp. Lisp doesn't have extensible syntax, but like everything is a list there anyway, so like all you need is a macro system. Linksider in Bevy. It was in Bevy, but it's not in Bevy anymore. It was in Bevy originally for the gem, and then we changed the engine to a custom engine. So it is in. Right now it's in this engine. No, my bot doesn't work. This is the gang. But I don't suggest you use the language, use the engine, just use Bevy or whatever, macro quad, something. I don't work on the engine too much. Did I just close this? Now we need to do this again. Filter, inverse, invert. Yeah, there you go. All right, let me continue. Figuring this out. So why do we need the polarity when I show this? I thought that so in order to show what the type actually is, it's either the union of the lower bounds or the intersection of the upper bounds. But okay, I thought I would be actually showing a range. Like in between the lower bound and the upper bound. That would make sense to me. Why are we only showing the polarity? Maybe when we infer the type, we... like, let's say that we have a function here, right? Once again, that's what we had before. We have a function that prints hello world. This is a function that takes as its context the right context plus potentially some more stuff, right? So this means that we have the infinite upper bound right now, but the lower bound is the fact that we need the right. Right? But in the end, when I actually if the type inference is completely done, then all that we are left with is just the lower bound, right? There is not if there is nothing else to be added, then we just use the lower bound as the actual type value, I guess. Hello. It's Void Chaos Father. Void Chaos. Father. Right. This is still just half of the paper. What is left in the second half? Examples. Now is a good time to pause and exemplify some crucial aspects of the simple sub. Recursive types. The reason for having recursive types in the user-facing type syntax has now become quite obvious. We need them in order to tie the knot when we're trying to coalesce variables which appear in the coalescence of their own bounds. Let polymorphism and recursion. So like one of the things that we don't have in cast right now is the let polymorphism. Rust doesn't have let polymorphism. I'm wondering if I will eventually want to add that. In traditional ML languages, local let bindings may be assigned polymorphic types. This requires keeping track of generalized typing schemes, which are to be instantiated with fresh variables on every use, and make sure that we are not generalizing those type variables which occur in the environment, which would be unsound. A better approach is to use the levels. Subtyping with the levels. We have variable state, which now has a level. The level of what? A level of polymorphism? How polymorphic is this variable? So level 0 means that it's not polymorphic, and level 1 means that it is polymorphic. Potentially? Hmm. When I do a fresh variable, we have an implicit level. Why is this implicit? I don't know. To the type term function and make it sure to type the right sides of let bindings. So the right hand sides of let bindings with a higher level than the current one. So when we have a let binding and non-recursive let binding, we know that the right hand side type is a variable with a one more level of polymorphism. Notice that in the context used to type the body of the let binding. Actually, like I kind of like this idea. Maybe I should have let polymorphism. If you don't know what this means, if I go into my REPL right now, right, and if I have a function that takes x and returns x, then this is a function from not inferred to like the same, like not inferred, but this is a function of a concrete type. We just don't know the type yet. If I know that if this is a function, right, and I call this function with 1, 2, 3 as an argument, right, then I know that since I've used it, this is a function from int32 to an int32, right? But technically, this can be instead inferred to be a polymorphic thing, like for all types t, x into x, where x is of type t, I guess, you know, something like that. So f1 to 3 is still 1 to 3, but f hello is hello, right? So we can use it with different types actually. This could be done automatically. This is called let polymorphism. Yo, ICS box. Hello, hello. How are you doing? How's your Rust going? Still learning? How long have you been doing Rust for? I'm not sure. Two years now, nice. 2 years, you should be pretty comfortable with Rust. I mean, it depends on how often you use it. I think like I became really comfortable with Rust in about exactly 2 years, but I was using it for those 2 years, like basically every day. Or I don't know, maybe every other day. Internet dev is just my passion, yeah. I mean, I'm a dev and it's my passion too, I guess. It's this what I work with and what I do just for fun is basically the same thing, almost. All right. I'm making a programming language, my own one, because Rust is not a good language, you know, anymore. I mean, it's a good one, but we need a better one. So someone needs to make a better language. So we are trying to do that. The language is called Cast. I'm right now looking into the inference with subtyping. I already have type inference, but in my type inference algorithm, I can only do the equality between the types, and I don't have the subtyping. Subtyping in Rust is only used for lifetimes, basically. I guess there is like one case of a subtyping which is not lifetimes, which is the never type. So in Rust, you have the never type, right? In Rust, you have the never type, and the thing is that the never type is a super type of every type. So like you can, or no, a never type is a subtype of every type. Yeah, I think so. So like you can assign the never, the expression of the type never to any type, basically. That's what it means. Because the expression is never going to actually be evaluated, so it can be any type, right? I think that's the only thing that has a subtype thing. Apart from the lifetimes. Alright, so I'm reading this paper. It's called The Simple Essence of Algebraic Subtyping. I don't know why I never read a paper before in my life. So today we are reading the paper, though. It's really easy, though. This one is simple. If I skip through the weird, like, mathematical notations, it's actually really easily understandable, I think. Let polymorphism and recursion. Yeah, so I was here. So I think that I will actually maybe add the let polymorphism there. For that, we need to, for the variable states, to add the level of polymorphism. The next step is to make sure that variables of higher level do not escape into the bounds of variables of lower level. We do that by adding guards in the constraining algorithm, preventing it from happening. So if I constrain the left-hand side by right-hand side, I can only constrain if the right-hand side level is less than or equal than the left-hand side level. Shouldn't I update the level to be the minimum, though? Left-hand side level should be more than or equal, I guess, right? So it should be the maximum of the current level of the left-hand side and the right-hand side level. Isn't that the case? Or should I never make it? Yeah, I guess that would mean that I am increasing the polymorphism. Yeah, that, I don't know. So what happens if it's more? Then it will just say that we cannot constrain like that. Type inference fails. Extrude. Okay, I think we can think about the let polymorphism and this thing a little later. It's an interesting thing, but I don't think it's very important right now. Simplifying types. As it is, the algorithm shown in the previous section infers types which often contains redundancies in their structures, as well as type variables which could be removed or unified. Yeah, that's what I was wondering about. An important component of type inference when subtyping is involved is to simplify the types inferred as to make them compact and easy to comprehend. If we did not perform any simplification, the inferred types would usually grow linearly with the size of the program. In this section, we explore the design space and trade-offs of type simplification. We recall how automaton-based simplification, simplification trade-offs. Part of the appeal of the algebraic subtyping is that it produces compact principal types, which are easy to read. Unlike previous approaches to subtype inference, however, this comes at a cost. It requires making simplifying assumptions about the semantics of types. These assumptions hold in ML sub. Full specification of term typing and simple. Yes, sure. For instance, ML sub considers the types int and nat. Int. What is this? What is this symbol? What is the symbol in math? No idea. I guess it's an intersection and this is a union, or maybe? Let's ask ChatGPT. What does this symbol mean? Join. Least upper bound of supremum. Oh, supremum. I mean, yeah. Have two elements in partially ordered set. If A and B are elements, then A and B is the smallest element that is greater than or equal to both A and B. So it's a union, yes. This is a union and the other one is the intersection. Sure. So we intersect the type int and nat. Right? So basically we okay. So because the functions are contravariant, the argument is going to be like inverted, and it's going to be a union of int and nat. So a union of int and nat is an int, because a natural is a subtype of int, right? So it's just an int. I mean, over here, yeah, a union of int and nat, but the function returns an int union with nat. So it's technically an int into nat. This is int into nat. Equivalent, although the latter intuitively contains strictly less information. The assumption is sound because programs cannot distinguish between the two types. Program which works with one will also work with the other. However, the equivalence would not hold in a language which, for example, used intersection types to encode overloading. As another example, ML does not distinguish between the types tag 0 payload stir and tag 1 payload int union, and tag a union of 0 and 1, and payload is stir and int. So here we see that we actually lose information, right? Yeah, we actually see that we lose information here. Because now we can have a tag of 0 and a payload of an int, even though that is the incorrect thing, right? Where 0 and 1 denote singleton literal types. Yeah, this is like a TypeScript stuff. But language like TypeScript, yeah, there you go, which support flow typing, the former holds more information. Yes, indeed. Isn't it more information in ML sub 2? Since the different types of payload could be extracted separately by first matching on the tag. Yes. These simplified assumptions are not necessary for principal type inference. They are merely a requirement of ML sub simplification and subsumption checking approaches. They are implied by Dolan's algebraic construction of subtyping, making them inescapable in his system. These assumptions can actually... You're actually reading papers though, Spike? What are the papers that you read? I think this is the first paper that I read in a while. The only other paper that I read was the Ghost Cell. Hello? Are we live?
I am experiencing profound cognitive arousal.
What does this mean again? I see. Arousal. That's a good word to learn. Sometimes I find paper of random topics. Light reading. It's not sexual. Yeah, no, I understand. It's just used in sexual context a lot, I guess, the arousal. Downtown. Um... Thanks to the simplified assumptions, clear subtraction, ML sub can represent types as finite state automata, where the states are type variables, and where the edges, which are labeled, represent relations between these type variables. There are 4 sorts of labels on any edge between the 2 type variables A and B. And is A label indicates that A is a subtype of B. Consumes label that indicates that A is a function which takes B in parameter. Produces label indicates that A is a function which returns some B as a result. And finally, A contains L, that A is a record which contains a field named L of type B. Sure. The starting state of the automaton represents the root of type expression. This clever representation allows one to simplify types by using well-known existing techniques from the domain of automata theory. Type automata can be made deterministic. The is-A labeled edges are seen as this edges. What is that? Epsilon? I thought epsilon is written like this, like a flipped 3, but this over here is different. You see how it doesn't have like the curve in the middle? But in every other like suggestion that I have here, it is. I think that's a different letter, no? Weird. Type simplification is simple sub, a more simple one. Co-occurrence analysis. An occurrence analysis looks at every variable that appear in a type in both positive and negative positions and records along which other variables and types it always occurs. A variable v occurs along a type tau if it's part of the same type union or part of the same type intersection. Based on this information, we can perform 3 kinds of simplification. Removal of polar variable. Like, when does this happen? Is this after or during the inference, though? I don't understand. Like, so far, I think it's after the inference. Does it matter? Interpreted representation of simplification. Formalization of a simple sub. Like, it's for simplifying, right? Because we can potentially have the same type specified in the upper bound, but I don't know. To be a big problem. Formalization of simple sub. Oh my god, this is scary. The syntax first definition of subtyping. Simplified algorithms and mutability. Soundness and completeness. Some lemmas. Experimental evaluation. To evaluate the strengths of both simple sum and ML sub implementations, we ran them on 1 billion randomly generated expressions of varying sizes. Yeah. Bugs found in ML sub. A variable shadowing bug. All right. I mean, this is the end. Okay, so there is something. I think like it's not very difficult to introduce subtyping into cast. And then we can also think about the polymorphism, the let polymorphism, eventually too. Okay, so what do I do then? What do I do? I think I just update my inference here with having the subtypes. Yeah. Okay. We might need to change a lot though. Can I have an inference algorithm that is separate? I think we can try making, like, I wanted to extract the inference into its own crate anyway. Maybe we can like test it independently of the entire language. Crates. Let's have a crate which is going to be called inference. Cast inference version workspace source lib. And are inheriting the version. I think this means that I should have the version to be equal to 010 here. So version workspace. I think I need to just change all of my versions. Version 0.1. Can I not specify the version here though? I mean, I can if I don't publish it to crates.io. Let me delete these for now. Mm, version workspace is true. Mm, mm. All right, I think it's fine. Mm, what's up? Hello, hello. How are you doing? Let me do everything except for the inference. It's just me changing the version. Of everything. Use a version workspace. It's okay. Here we go. The inference. I think we can just start by moving the inference into course. Yeah. So right now it's just a module. I just take this and I move it into the crate here. It doesn't even require anything. There's randomness that I use. Sure, we can add that. Inference. No, inference is not a proc macro. Hold on. Rand. Can I do that? And also IRE. Sure. Eventually I will want to have my own error. Probably. Alright, so we'll do cargo test, package, cast inference, right? And why are you compiling SYN? Oh. There is also the try hash and any map 3. Okay, any map 3. Try hash. Any map 3 is not there. Any map 3. Like this. Alright, identifiable. Using identifiable for IDs. Okay. There is also the show short. I think those can go into the utility package here. Show short ID. Do that. Who's crate ID? Who's crate? Show short. Create module, create module. Identifiable is this. We just have the ID, a thing which needs to be hash. Sure. And then I also need the show short. Biggest associated type. In the inference. Because I need the utility here, yes. It's util. Is that it? Util, not there. Did cast util? There you go. Hello, Deagle. Hi. Alright, so now we cannot find create identifiable because it's not create identifiable anymore. Cannot find trait identifiable in the scope. Because this should be use you cast util identifiable. Yes. Let's just import everything from there, maybe. This is in the inference. We do the same thing. Wait, I do use cast util star. Unresolved module. Wait, why is it still unresolved? It's literally here. Hello? It's because it's the fake error. Didn't find recurse cache. Okay. Yeah, for recursively showing the things. Display for not inferred. Yeah, that makes sense. Let's just have the recurse cache. Recurse cache just has the AnyMap inside. Have it here. Mod recurse cache. Mm -hmm. Mm -hmm. Jerem. Hi. Hello. All right, so it actually checks still. So now I can try testing just the inference. Okay, so the inference right now is completely empty. Okay. Maybe let's try actually making a test. What would I test here? Running one test. Okay. This file is not included in any crates. Are you sure? I think you're being stupid a little bit, Mr. Rust Analyzer. Restart. Yes, yes, yes. Restart. Also, right now the inference is a little bit weird. How many lines of code? We have 500 lines of code in the current inference thing. Okay. So the let's just see how it's been used. I can have simple inference right now test. Let's see. Implement. Let's see this struct. The thing that I'm going to be infer is going to just be an integer. How about that? Use cast. So why do I not have the auto completion here? This stupid thing. No machine language servers. I hate this. Better try restarting. Now it's working. Okay. But for some reason was thinking that it's not part of my code base. And it was not using the analyzer here. So use cast util and use inference. Let's do that. So I'm going to, so here's how we use this crate, right? We implement inferable for the thing, right? And right now, all we can do is we can make two things to be the same, right? Inferable must be clone. Okay, sure. Derive clone. Debug. Clone. Partial equality. What else? That's it. Okay, so if I want to make the same A and B, right? This thing self A, self B. Let's do this, right? So I say that if A is not equal to B, then I reveal A is not equal to B. Just like that. Otherwise I will return okay self A, right? That's a very, very simple thing. We just infer integers instead of inferring the types, right? And then I say maybe not inferred thing, right? Is maybe not inferred new, not inferred A, right? That's how we do it. So A is not inferred A. Then we say that B is not inferred B, right? Then I say that C is not inferred C. Then I say that A we have make same, which is taking this mutably. I think this should be a little bit of a different API, but sure, let's have it mutable here for now. I think I will change the API here a little bit. Um, so the tests can return results in Rust. Can we just say that we return result? And it's just going to work. So A is going to be the same as B. Different APIs, yes, bitches. I think that's how I do it usually right now. So we know that A is the same as B. I know that B is the same as C, right? And then I say that one of them, like C, is going to be inferred as. So like for some of these, we know the concrete value. So this is going to be a thing, 1, 2, 3, right? And then we will just int. I mean, we can just assert that A infer. I don't have the autocompletion inside macros. Amazing. A inferred. A expect inferred should be equal to also 1, 2, 3, right? That's what we do. So like we now know that all A, B, and C are 1, 2, 3. Right? That's the simple test for the inference, so it works. All we need to know is to make sure that all of the 3 variables are the same. We say that one of them is known, so now we know all of them. It's very simple, right? Now, in the context of a subtyping, right? In the context of subtyping, it will be kind of similar. Test 3 and let's call this test 3 ints, and this is going to be test subtype something. So it's going to be very similar. I can still do this on ints. So let's say that this represents a type, right? Let's say that this an int. Let's call this like int less than, you know. So we can have in the type system integers that are less than a certain constant, right? And this thing can have subtypes already, right? So because if something is less than 2, then it's also less than 5 for sure, right? So we can do something like that. So in this case, since this is inferable, I need to like the way this is going to work, I probably, instead of making same, we need some different thing, right? So in the paper, they call this operation, what do they call it? Constrain, just constrain, right? So constrain left-hand side with right-hand side. This means that the left-hand side must be a subtype of the right-hand side. That's what we need to do for our inferable things, right? So left-hand side and right-hand side, constrain. And in this case, they don't need to be equal. If this like is a subtype of that, this is for like already inferred types, right? It means that I need to know what paper is that. It was a paper about the simple essence of algebraic subtyping. I just was googling how to do a type inference with subtyping. Type inference with subtyping made easy. All right, that's what I was searching for. It's actually not that difficult. Like even I understood that. If you skip through the parts that you don't. So like this is how we want to use it though, right? So the thing that we want it to be used as is to constrain variables. Instead of like previously I was constraining them to be equal, I was making the two variables to be the same. Now I need to constrain one to be a subtype of the other, right? So in this case, for the ints that less than that, I need to check here that left hand side should be a less than or equal than right hand side. That's literally the condition of us being a subtype, right? Then I return okay, self. So now what is the result though, right? So previously I was like merging values into a single value. So I could have some information known from a left hand side, some information known from the right hand side, and I was returning a combined value, which is like, what is their like common thing? I think now I don't need to do that, and this should just return a result. So like in this case, it's just okay, right? And in this case, it's just going to be an error. Left hand side, right hand side. Something something, right? So this is the new thing. I guess in this case, let's just rename this in our inference engine then. So if something needs to be inferable, now we just constrain two things. I mean, this is basically checking the constraining. I mean, it is constraining, right? Because it can be like recursively constraining something inside. For integers, we don't like do anything recursively, obviously. But yeah. All right, I think in this case we can have a reference actually. I think we don't need cloning. We'll see. But I think the API should be something like that. Right? I think that's what we should do. So if it fails, then it should like return some report to me. Okay. All right. Okay. Now we we have default value support too. Default values. I wonder how this would actually like work with default values. Like, should I have both making things equal and having subtypes? But in order to make things equal, all I need is to have the subtype relation in both directions, right? Because if A is less than equal than B, and B is less than or equal than A, then it means that A is equal to B. So I think it's not really needed to make it a separate operation. In this case, we have default values. Default value. I think I need to remove the default value support for now. Let's actually remove everything. Do we now get HM type system? We already had HM type system. This is better than HM. HM does not have the subtyping. The only thing that we don't have from Hindley-Milner is the let polymorphism. That's the only thing that I don't have. as far as I understand. Like, I had it for a long time already. Scary OOP terms. It's not from OOP. Look at this. Subtyping from functional languages. Do you even see OOP here? This is ML sub. This is functional programming. It's not OOP. ML sub has nothing to do with OOP. Prototype type inference engine. I guess it's a type inference. Like it's for ML-like languages, for subtyping and polymorphism. Written in OCaml. Subtyping is used a lot in OOP though, languages for sure. But that's just one example of subtyping. You can have, like, I guess a good example of subtyping would be like refinement types, I guess. Like, literally, this thing that I'm making as a test. By the way, Dev Ninja, did you see that? I'm writing a test before writing the the actual implementation here, right? So Rust doesn't have this, but we can have refinement types probably in the future. I will probably have it. So like we have I32, which is less than 10, you know? So like it's not just an integer, it's an integer that is less than 10, right? And so if you know that an integer is less than 10, then you can use it in any place which expects an integer that's less than 20. That's like also a subtype relationship. It's not only for like inheritance and stuff. All right, I think I'm going to like delete a lot of functionality from my inference right now. One of them is default values. So we are only going to have a description for a type variable. We're going to have the actual value. So yeah, and now we are not going to have the value actually. Let's just also only have the description for now. Run checks. I'm going to remove that. Let's represent these guards in the same language as everything else. The lines are going to be even blurrier than zigs. Yeah. Refinement types are refinement type. I mean, we also might like I think we should be able to have dependent types because like we have compiler as interpreter, but refinement type is like a simpler idea where you just say that you have like a natural integer that's more than 5, right, or something like that. We have so there is like liquid Haskell for this. There are other examples of languages with in more recent times, refinement type systems have been developed for languages such as Haskell, TypeScript, and Rust. Wait, what? What is this? In 2023, Flux, liquid types for Rust. Oh no, it's another PDF file. Flux, liquid types for Rust. Ah, yeah, no, I remember seeing this, yeah. So, like, you have annotation for the actual, like, refinement types using the, like, the macro system with this thing. You intend to release the language for free. It's already there for free. You can see everything that I'm doing right now. It's on GitHub. Yeah. So, but it's not a native thing in Rust. There are like languages with native support. Liquid Haskell has that. Down. What about TypeScript? Refinement types for TypeScript. From 2016. What is the actual link? This one? We present a refined TypeScript, a lightweight refinement type system for TypeScript that enables static verification for higher order imperative programs. I have procrack macros, but I would be happy to see them gone. Yeah. Same. Oh, I cannot even like. I need to pay for this. For refinement in TypeScript. Okay. Anyway. So we have data. This is the data that is stored for a variable. Right now, I only will store the description. Previously, I was also storing there the actual inferred value, right? But now, instead of storing the inferred value, we're going to have bounds. I will add them later. The variable state. I think I don't need this anymore, actually. So I was using the data structure, which is called the disjoint set union, right? Because we like previously, like I was saying, when we have two variables a and b which are equal, then once we know that they are equal, we just treat them as a single variable. So all of the variables that are the same, we just merge them into a single set and treat it as a single variable. But now with the subtyping, it's not really the case anymore. I think this also can be completely deleted. Global state. Let's also get rid of the global state and have like some other way of doing this. I think maybe Devin's dev, hello. I think we maybe just write everything completely from scratch here. Maybe I just write everything from scratch here. Sure. So when I say maybe not inferred, I don't know why even I had that. I say maybe not inferred, but this should be just a variable, I think. A variable, a new not inferred variable. You should start a cult? No. The language for the next 80 years of AI incursion. Hmm. There's 3 ints. Okay, so that's the same. Okay. So instead of making the same, I mean, I guess we can say make same. Let's have make same, sure. Make same as B, and B make same as C. I think I can have this, but a make same can be so we have a trait inferable, right? A trait inferable where we have a constrain self with with like constraint, like how do you call this? Self something. So this is what we should implement. But if I say make same self as the other thing, then making the same is just the same as constraining self with the other and constraining other with self, just like that. Right? This probably should be called different. It's not it should be not constrained. What do you call this thing? So like for types, it's a subtype or supertype. But in general, what would that be? It's not only about the types. We don't only infer types in cast. Like just I guess like like a superset, I guess, in general, right? Just a set, superset. Maybe. We can just call this super. Or whatever. I don't know. Let's call it superset for now. Why functional forecast? What do you mean why functional? I mean, it's not exactly a functional programming language. But a lot of the ideas are from functional programming languages. Is Rust functional or something? Because Rust is supposed to be kind of similar to Rust. Like I was saying before, I'm not even sure what functional programming means anymore. What is functional programming? When you I like, as far as I understand, when people say functional, is that when all they write is functions and everything is a function. Yeah. So like functional programming causes behavioral boundaries to emerge more obviously than designing imperatively. It's like you're playing Sudoku feeling. Yeah, I mean, yeah. But at the same time, like when you're writing Haskell, for example, right? Haskell is a functional programming language, but you are all like you work with monads a lot. You are inside the do notation, and you kind of write imperative code anyway, right? So like there are a bunch of articles like Haskell is the best imperative language, or something like that, right? Why is Haskell referred to as the best imperative language, right? Because like you write the code imperatively, kind of, right? But under the hood, it all like boils down to the functional stuff. I mean, this is just a little bit more ugly, I would say, than something that you would write in Rust. So they use like IRFs here for mutable variables, right? And stuff. But yeah. I think you can have like a better thing. But yeah. Search for Elixir is the only good answer. The answer to what? I know Elixir. I never tried it, but I mean, yeah. Elixir is not very good in my opinion because it is dynamically typed language. I don't like dynamically typed languages unless they're as far as I remember, right? Yeah, it's dynamic. There are even like type systems here. Like, how do you even write code in dynamically typed languages? It's pure pain. Did they ever come in to let you know you're the best programmer ever? I don't know if I'm probably not the best programmer ever. Otherwise, cast would be ready already and Linksider would be been released fully, and we would have earned millions of money. Or to use any functional programming It would 100% be Elixir. Why Elixir and not Haskell, for example? Like, I mean, just by the fact that Elixir is a dynamically typed language already means that it's inferior to Haskell. Or, I don't know, OCaml is kind of a nice language, I guess. What is, why do you think Elixir is better? What is the thing? Like, I mean, there is the Erlang virtual machine, right? What's good about Elixir? Like, the best part of Elixir is just that it's running on top of Erlang VM, right? So you have like the whatever it provides, low density distributed and fault tolerant systems, right? Pascal requires too many wrinkles in the brain, the amount of terminology. Yeah, maybe. What about Scala? Maybe Scala is a good language too. I heard a lot of good things about Scala. Scala has a type system. Yeah. The only bad part about Scala is it's running on top of the Java virtual machine, though. if for Elixir, the virtual machine of Erlang is a good thing, maybe. Not sure if it's a good or a bad thing because I never tried it. But for this Scala, it's probably a downside. Imaginig, hello. It will seek out the math if need, deep knowledge, but Haskell forces. Yeah, Haskell forces the deeper knowledge. I guess that's true, but isn't that the same like with Rust, for example? When you're writing Rust, you are forced to understand lifetimes. It's not really like about the math though, I guess. So it's like for a programmer brain, I guess lifetimes are easier to understand than like a monad when you're learning for the first time. Okay, we have a variable of inferable values. That's what we want, right? Let's see what our public API is. We need to have a simple variable, public function new not inferred, and this should return self. Okay. Variables are clonable. T inferable clone for var. Isn't a model just fancy composable associated behavior? It has an effect when changing or reading data from some inner thing. A nice little reader. Did they fail? I don't know. If anyone who doesn't know what a monad is reading chat, did you understand what Spike explained? I think no. I think that's not really understandable by a human. Let's see if ChatGPT knows what a monad is. That's actually pretty solid intuition, says ChatGPT. ChatGPT understood you, but I don't think a person who never heard of a monad would understand it. And type parameter t is never used. Yes. Data. So I think I just do an arc mutex data t here. Clone self data clone. New don't inferred self data arc new mutex new data. Description. As ref stir. Is that what I do? All right, and then we have phantom data. Let's have for now phantom data of type T. Yeah, so this would be a constraint. Self superset self. So if this is two integers, I just must say that they are the same. Till that light reading, my friend, and now my ex-boss make fun of me for sounding like an LLM. Really insulting, actually. Your ex-boss. Did you lose your job? I thought you were you were an intern, right? And then you lost your job instead of being promoted. Or did you find something better? Okay, so if the thing must be equal, in that case, let's have an int here. Like, this is a concrete thing. So the thing here is that for integers, when I'm inferring them, the constraint is not, it's not just a superset. Constraint is the same as making the things same, right? So I just should say like the superset also should be constrained by self, right? Like, kind of. But this is just a recursive thing, of course. Let's see. If self 0 is not equal to superset 0. Let's just do that. Yeah, I didn't get it up visibly frustrated. Okay. What is this? The method exists for inference variables. Yeah. Okay. So now we have the variables, and if t is inferable, then variables are also inferable, right? So constraining this with that, we're going to have a to-do here. Yeah. All right, then we have an infer as thing. So when I say infer as, it means that it must be exactly the thing, right? Yes. So this is our API for inference variables. I can create a new inference variable, and I should be able to say infer as some value of type t, right? When I infer this, do. Infer as takes a self as argument, right? Okay, and then expect inferred is something that gives me the value back, right? But I think we should just have inferred. Should give me the optional D. The result T, sure. Method has a self-declaration. No more cloning. Like so. Expect inferred. Like this. I think this test should be ignored for now. Test. How do I ignore the test? Ignore? Or is it just ignore? Okay. S3ins, not yet implemented. Alright. So this is our API. Okay. So if I have data for each inference variable, we now should have the lower bounds, which is going to be a list of lower bounds, and we have upper bounds, which is a list of upper bounds, right? Like this. No more phantom data is needed. Randomness, probably not needed. So when it is not inferred, lower bounds are empty and upper bounds are empty, right? When I infer this as a thing, I think maybe there should actually be the thing which says infer as subset of some superset, right? Like this, you know? There should be infer as subset and infer as a superset. I think both of these. So when I infer as a specific value, this is same as inferring myself as both a subset of t of value and infer as a superset of the value, right? Like so. Let's have a reference. So if something is a subset of a superset, then it means that the superset is my upper bound, right? That's what it means. All right. Data is self data lock. And I say data upper bounds push superset, like so. But also this means that all of my current lower bounds are also a subset of a superset, right? That's what it means. So we go for lower bound in data lower bounds, say lower bound. So this one is the inferable. I need to constrain the lower bound. So this over here, right? I say that inside the inferable, I'm calling this constrain. So maybe this operation should be called infer as a subset of, right? Infer as, like literally the same names. And then I also can have infer as a superset of a subset. This will just say subset, infer as superset. Subset, infer as subset of a self, right? That's it. So now these are the three operations, right? Either we are a subset of something or superset of something, or exactly the same thing. That makes sense, I think, right? But I only need to implement one of these operations. Lower bound, infer as a subset of the superset, right? Is that it? So T does not implement clone. This means that inferable things must be clonable after all, I think. Something is inferable, I think I should be able to clone it. Okay, infer as a superset of is very similar, but instead of doing the upper bounds here, we push the subset into our lower bounds. Then we go for upper bound in our upper bounds, and we make every upper bound should be a superset of our subset, right? That's very simple. So this means that when I want to know and infer the value, what we actually know is like is all its lower bounds and all its upper bounds. So it's not necessarily a value of type T, right? I mean, is it? Maybe. So, I mean, maybe like it means that the inferable values should know how to construct a union and something. And union and an intersection. Not all trait items implemented. I don't like this, where it doesn't write the file automatically when I am renaming things. Infer as, okay, this now requires a reference. I think I like that. Inferred. Int doesn't implement debug. Okay. Yeah, I guess we can implement stdfmt debug variable t. For now, it's just going to be a variable. Operation equals cannot be applied to typecast inference variable. Wait, what? Inferred should be a t. This is a variable of ints. An operation equal can be applied for typecast inference of variable. Oh wait, it's a variable int. Wait, what? Oh, it's infer as. Yeah. Uh, yeah. Okay. A dot. So there is infer as, but I should also make sure that two things are the same, right? When I say over here, infer is a subset, a superset of. This takes the concrete value, but it should be able. I should be able to construct the variables here. This should take either a variable or a thing. And I should be able to do that with subsets and supersets too. Okay. Infer as value type t. Okay, so I think infer as this should take variables, right? Because it potentially uninferred, right? Yeah. This means that the lower bounds and upper bounds should be not just list of values like this, because those might be not inferred things yet, right? Verbal. Infer as variable I mean, I can just do this dot into, I guess. So I should create the implement from t for variable t. Self no. Let's do that. Should be like a little different. It should be a little different. I think it should be an enum after all. Or maybe data should be an enum over here. Maybe this thing should be an enum. Either we actually infer the thing, or I know the concrete value. Or maybe upper and lower bounds should not necessarily be variables. It should be like a maybe variable. Maybe like that. Derive clone. I don't think I need to derive clone for data. So yeah, this over here, when I say infer as a subset of, should take the result is self new all inferred known value known result or as maybe variable value. Here we do unwrap because it must succeed and return the result. So this thing should take not a superset, it should take a maybe variable. I kind of want to have like references there, but then it doesn't really work. So should this have a lifetime? And then this would use the static lifetime, I think. Similar to cow, you know, like value reference. Let's do that. Yeah, sure, whatever. Clone is not implemented. Yeah, so I need to implement t inferable variable. I mean, not even clone. I kind of want just to have function to static clone static kind of thing. Maybe I probably like, yeah, I guess like into static self or static p. So like I just clone the value in this case. The parameter t may not live long enough. Yeah, inferable must be itself a static thing, I think. All right. So just a maybe variable, like so. With anonymous lifetime. So here we don't do superset clone, we say superset into static. I mean, this should be cloned. Yeah, the upper bound should also be like done before. Clone static. This should take a reference to self. The variables are clonable. The values are clonable. Everything is clonable. reference to reference. To T clone value. Maybe this. Okay. So infer as a subset of superset. Okay. So it's a little like weird. So compared to this paper, the difference is I don't store the so yeah, here you go. They have like types, right? Since this is for type inference. A type inference is one of these things or a variable, right? So instead I don't instead of like this part is its own type, something that I want to be inferred, right? And this is a special case. So in the that's why we have this is a maybe variable, I guess. Is that why I had a maybe not inferred thing before? That's probably the reason why I wanted that. And we also have like a reference here to the thing in addition. Mm -hmm. It should probably just like be a trait though here. Superset is something that can be. I don't know. Let me think here. So say lower bound infer a superset. So like I need these three methods, you know? I need these three methods. Infer as, infer the subset, and superset of. And then maybe variables too, right? So we can, yeah. Yeah. So it's like it's all the same. Probably should be like in a trait because of that. But I want to infer this as a subset of what? Of self? In this case, or not self? I think self. So in this case, a superset of, we just say subset, infer as a subset of self, right? So literally like the same as the default implementation there. So this is the only method that I actually need to implement. And this is where I'm going to match self and superset. So technically, I mean, I only care about these two variants. Let's try removing the lifetime. I think I maybe can clone later. Or do the reference with a trait, something. Clone static. Like, I don't need clone static. I literally just derive clone here. Okay. So this is our things. If both of them are values, this is the most important case. The value, self value, and superset. In this case, we use t as inferable. Infer as subset of, like, self value is to be inferred as a subset of the superset, right? And that's our result. That's it. If I have now a variable and something else, variable, variable and superset. So in this case, we don't really care. So these two can be the same thing. And in this case is a subset. So like either one of them is a variable or none of them are variables, right? So in this case it's a subset and a variable superset, or it's a subset variable and a superset as potentially a value, I guess, right? Yeah. Yeah. So I think this is where this code actually goes. Inside of this code. So this is going to be subset data, is a subset data lock. So then superset is going to be just cloned inside. And then we lower bound, we infer all of those as supersets. Okay. And then this here is very similar, but the other way. So we say that superset data is a superset data lock unwrap. This might be like having a deadlock. I should look into that. Do deadlock. There is definitely going to be a deadlock here for recursive data structures. So I need to do something, but we need like to recursively go over them. I can clone these out, I guess. That would be, yeah, maybe let's do this immediately. Maybe let's do this immediately. Subset upper bounds is, you know, subset lower bounds. Subset lower bounds. Subset data, lower bounds, clone. I think like this. So I'm going to clone all of the lower bounds. Is this way I don't unlock the thing, because I should not be doing that, right? Although, wait, hold on. If we are doing it recursively, no, it can be, yeah, no, it can happen recursively for sure. Wait, how do they do this in their like literally this implementation here? I mean, they basically clone it, right? Because it's a functional programming language. So when they say that they are iterating over a thing, they are basically iterating over the original copy, all over the original value, right? So if they modify it, yeah, when they say upper bounds for each constraint if the constraint is going to modify the upper bounds, then like it doesn't matter because I'm using the original value here. Yeah, they definitely clone it. So for it like to work faster, we could use like an immutable data structure, which is cheap to clone, which is what they do probably. Okay, so we then do the same thing here. We go for superset upper bounds, superset data like this. We push subset. I called it subset. So this is going to be pushed into the lower bounds, and I return the upper bounds. When we iterate over the upper bounds, and we infer the upper bounds as a superset of the subset. Like this. So this is the code. Now infer as subset of should take a maybe variable, yeah? Sure. But I'm just saying that this should be basically like an impl into maybe variable t, I think. Right? So when I infer this as a subset, then I say superset into infer as a superset of self. Right? Infer as a superset of, or maybe variables, takes a reference. So this should be a reference from self dot into, kind of, right? Yeah. So I think, yeah, I think that's nice. So we have a trait into, no, not trait. We just say implement from variable t for for maybe variable t self variable variable. Do the same for t. Value weight bound from a reference is not satisfied. Yeah. I think I should have a custom thing though for it to work. Either that, or I can implement like from reference. So in this case, I would clone the value, right? And similar to that, I will implement for from reference to variables. I just clone the variable. Cloning the variable is cheap. Okay. So this now does not take. So subset in this case is impl into maybe variable t. How far am I with this language project? The biggest achievement so far is that I solved 8 days of Advent of Code with it. Hello. But it's there's like a lot of things not there. So right now I'm implementing inference. I'm re-implementing inference from scratch with having subtyping in the language. Previously, the inference was without subtyping, basically. That's it. It's already open. You can try it. We have online playground. Look at this. The website, I still want to update it sometime, but like some of this is old. You can have playground even here. I compile it to WebAssembly, and you can run it in your browser like this. Look at this. So you just run, and you have a hello world over here. You can have like dbg print or something. So like print, for example, is a function from string to unit, you know. You can try things. There's not much documentation though, I guess. But yeah. I also used it in my bot a little bit, so I think the like in terms of like putting it to use, I have a little bit of code in my bot, but I need to implement more like built-in things. Right now, what did it do? Let me see. Source. To have a bot.ks now in terms of cast, right? So I have yeah, there you go. If we do exclamation mark pigorly, then it's going to, oh wait, I didn't recompile it. That's right. I probably need to like recompile it for that to work. Let's do it right now. I just go to Nix files and then I say Nix flake update input could be bot, I think, something like that. How do you do this? Update inputs. Oh, you just say update could be bot like that. No, it doesn't. It's so like right now I have an interpreter. So right now the interpreter is being compiled to WASM. The interpreter is written in Rust, and the interpreter is being ran in the online playground. I'm not actually emitting the LLVM bytecode. So the language is not compiled yet. It will be compiled later. So the immediate use case is to use it as an embedded programming language. So like I was talking about my bot, right? We have a little bit of cast code embedded inside my Rust code. So like my bot is written in Rust, so I'm connecting to Twitch API using some Rust code, right? And then I just use it like as an embedded scripting engine. So I just call some cast function here. So yeah, like until I implement more of the language, I will like use it like that, I guess. Hold on, Pigorly. I need to also rebuild it. Okay, there we go. Once this is done, it could be bought. We'll rebase. This should update the bot. We'll see if it works. The dream language would work equally well, either interpreted or compiled. That's exactly the goal that I have, yes. So, like, the reason I start with interpreter is because we have a comp time, like in Zig, right? It's not exactly like in Zig, but yeah. Basically, you need to be able to interpret code at compilation time, so you need an interpreter anyway. The same functionality is also required, as far as I understand it, for implementing dependent type systems. Because dependent type system needs to potentially evaluate some code. for the purposes of type checking. I'm not sure if I can like just do dependent types right now or not, but we should eventually be able to have dependent types too. And as the example on the thing, on the over here, compiled or interpreted, right over here. So here's my actual use case eventually that I want to have. I want to be able to transpile my code to multiple things. So like at compile time, I will invoke a compiler that compiles it to like some other target. So I want to be able to compile some piece of code to GLSL for my shaders, some pieces of code I want to like compile to a native executable, and some pieces of code I just want to have as an embedded scripting language, so I don't need to like recompile for a faster like cycle, right? So like all of that, so like compiling is also just, I guess, a library functionality is the idea. This is possible and there is no mainstream usage of it yet. Well, I mean, there's Zig. Zig is like popular because of its comp time, right? I don't know if Zig can be considered mainstream yet. Most popular programming languages. TOB index. Is Zig even up there? Is Rust up here? Hold on, Rust. Rust is top 18. Zig. Zig is number 50. Actually not that bad. Right under D language, which also has like similar comp time things. Yeah. What you wanted a rock to be, really? Rock. How you that you mention it again? I don't remember why I never tried this language. A fast, friendly, functional language. Like why rock instead of something? JSON deserialization via type inference. Does it mean like with compile time reflection? What does that mean? Their platform's concept replacing compilation targets. The target provides a DSL like STD. Oh. I think like my platform concept is more similar. Like I think like I never tried Rock. Maybe they have the same thing, but the platform support is more like what you have in Nix, right? So like if you look at the Nix packages, then what Nix packages is, it's actually is a function which takes as an argument the target into which you want to compile, right? So like system is basically the platform, your compilation target, right? And you can technically, I guess, in Nix refer to a different system by doing that inside all of the same process, right? So similar to that, our standard library would also be, I think, like a function that takes target as an argument, although that probably is going to be like an implicit argument. I have very strong opinions about how Nix package is supposed to be instantiated. Still being compiled. I'm compiling request. I mean, the bot is supposed to automatically restart, I think, once that is done. All right, what are we doing here? We just say for this subset.into.infer as subset of self.into. There we go. Easy as that. Infer as also should take value, which is impl into maybe variable b, and then I just say value dot into dot infer as self dot into. There you go. Okay. Maybe var is more private than the item. That's right. I guess I will need this to be public. So this would be like what? Maybe not inferred. That's what literally maybe not inferred. Right. Let's call it maybe var. I'm lagging because I'm compiling my bot right now. I can feel it. What's your opinion about Nix packages and in their instantiation, though? Stream is okay. Yeah, I think stream is okay. The trade bound never is inferable, is not satisfied. What do you mean never? Hello? A is of type variable never? Hello? How did you infer this? Okay, let's just give it a little bit of a type annotation. This is a variable of int, right? There you go. Variable int less than. Wait, it was. Wait, what? That's weird. Okay, so infer as. So now I don't need to do the into here because this is taking a trait. But the borrowed expression implements the required traits. Yeah, so I just infer as an int less than 1, 2, 3. There you go. Infer as int. Nice. I don't give a fuck about Nix packages, says in the dev ninja. Well, there is a little bit about Nix packages for you from Spike. I had a very heavy hand in the design of all the flakes in Hyper WM, which is this is where it starts. Keep it simple. People don't understand how all powerful this is. Oh, that's like what you suggested that I'm doing. Yeah, I'm using this thing myself. Yeah. Now. Oh, I mean, you're talking about the overlays here specifically, with self overlays. Yeah, I mean, yeah. I mean, is there like another? Wait, what's the other way of doing this? What's exactly the opinion here? Like how overlays should be used? Wait, hold on. Did the bot not restart? It recompiled. Reload on user units for man. Hold on. Big Orly. Doesn't work. System control user restart bot. Let's try that. Big Orly so broken. System control user status bot. Oh wait, hold on. It's I think it's failing. Maybe my user, I mean, maybe my bot was just broken. That's what happened. No such file or directory. That's right. Wait, what file or directory? Wait, what is this? What is this that I have in my Nix store? Why is the Nix store vendor cargo depths? Isn't this supposed to be like a hash? Is my hash literally all E's? Okay, so cast cannot find something. All right. I'm not going to look into that right now. So, okay, hold on. And embedded is standard library. Finished evaluating expression. Debug. No such file or directory. Source main 88. Maybe I didn't commit it? No, I did commit it. I mean, this doesn't work. I just try to evaluate the file source bot ks. Yeah, that's right. And then I'm not putting it into the flake. That's right. That's right. Okay. That makes a lot of sense. This file, the cast file, needs to be in the Nix store for this to work through Nix. Okay, I'm not going to do it right now. I don't care too much. Maybe off stream. All right, what do we do? Binary operation. Okay, unused variables. Sure. Cargo test inference. Okay. Runtime error, stack overflow. Amazing. Amazing. We have a stack overflow. Okay. So why do we have stack overflow? Let's take a look. What is happening, right? So I'm saying, I'm pretty sure that we are stack overflowing over here. Oh, yeah, you don't know the type now, yeah. It's fine. Print yo. What's the thing called? No capture. Wait, so this actually worked. Yo. Maybe I only print one of those yos? Yes, okay. So I stack overflow over here when I try to infer something as a known value. Okay. No, I mean, it makes sense. So when I say infer as, right, what is actually happening? The LSP cannot find the definition here because it's stupid, of course. Of course. If I do this, I mean, whatever. Mm-hmm. You didn't read the joke fully, I can tell. Maybe ask on Stack Overflow regarding the Stack Overflow, but only if it doesn't overflow the stack again. Yeah. Okay, so when I say over here infer as, right, I infer as a subset, and then I infer this as a superset, right? So what is happening is so this value is an actual value, right? So I infer self as a subset of this. So me, I am a variable, right? A superset is not a variable. So this will actually work, right? I add myself into the upper bound, right? And then we go the other way around, right? I infer the other thing as a superset of this. So we go over here then, right? And we infer our own upper bound as a superset of ourselves, right? There you go. So I basically I'm trying to make sure that the value that I'm inferring, like that this int 123 is a subset of itself, right? Yeah. So that it's equal to itself, basically. That's what is happening. So what we need to do is we need to have the caching mechanism if a variable has already been tested against a thing, then I should not test it against that thing again. Right. That was also written in the paper. I mean, it makes sense, so that's what I need to do. Right, I need to take a break, though. Be back in like 10 minutes. Yo. All right. So here is the thing, right? We need to not add the relations between two things twice if it was already done, basically, right? Right. But the thing is, we have variables and we have values. The way they did it in the paper that I was reading, the simple essence, was really kind of very similar. Coalesce, no, it's before coalescing. Do you have valuables? Well, we should call variables valuables. Because variables are the things that have values, right? So here's the thing. When I say that one thing should be a subtype of another thing, we have the cache, which is basically a set of tuples, right? Which pairs have I already configured? And over here, we just say that it now has been properly configured, right? Right. But the question that I have is, what is the semantics of this set? It really depends on the language. If this is like classes or something, because this is Scala, right? Then two values here are considered to be the same if they are like having a different like pointers, or like by like if like the references are different, or what? Or maybe it is still by value, but since variables are variable state, like do I like, because this is a class, right? This is in enum. Like what's the thing? But I think that maybe this enum is actually being treated as the normal thing, right? But then the variable state is equal to another variable state because it's a class, is only going to be equal if it's the same, like reference to the same class, basically. I think that is it, right? This is a class, this is like a data type. Probably. But I'm not sure. Class. If I search for class here, remember that variable state is a class and not a case class, or not, it's not a data class. This means that each variable state instance is unique and distinct from other instances. Yes, so like this is the important part. Yes, that is like the important part. When I right now am saying, so like if we take a look at my values in the actual cast, right? I'm doing it a little bit differently. So I have a value, or like let's say type, right? So we have types. So the types, they inside of them can contain other types, right? So for example, a list of another type, right? So type itself is potentially the uninferred thing, so it's a variable. But the variables, the way they were done, they are considered to be equal. Yeah, they are considered to be equal. If the inferred values are equal. So like I'm trying to look deeper into the actual inferred value. But for the sake of the equality here in the cache, I don't need that. So like I need multiple different implementations of equality. Right? I need multiple different implementations of equality. And here we like, this is actually interesting. We have so like we have traits in Rust, right? And we can only implement a trait for a type once. Is that a feature? Or is that like a big limitation? If you have so like this is where I guess like in you know, camel or like in ML modules, because they don't have traits, you can pass you can pass the implementation always explicitly. You can have multiple implementations that way. I don't remember, like I was reading something about this, like traits are local maxima, this thing. Yo, Spike, have you seen this? Traits are local maxima. So basically, it's not the best thing ever. But what are the other better things? Scheme that one, but don't remember well. Well, basically, the idea is that I guess the like what is a trait implementation? Actually, right? And the way it's implemented in cast right now, it means that my compiler, technically, it basically has a global state, and a global state is like all of the implementations. So like basically a map, like from trait and type to the implementation of the type, kind of, right? I think that's literally how it was done right now. Let's see here, cast, right? Yeah, we literally have the cast map where like if I want to cast one thing to another thing, this is literally a global map in the compiler, and I'm using just this casting as like traits. So basically, when you say implement trait for type, you are technically modifying this global map. Why is it global? Global state is bad, right? What if we had instead like what if we instead could insert the implementation of a type into a specific implementation map, you know? This way we could have multiple different ways to get the implementation of a trait. Specialization. It's not about specialization, because like specialization doesn't allow you to have multiple implementations of the trait for the same type. Specialization is allowing to specialize more concrete, to specialize the implementation for more concrete types when you have generic implementations, I guess. But in the end, even with specialization, you still have only one implementation of a specific trait for a specific type. You know? Like, you cannot have You cannot have implement foo for I32 and then implement foo for I32 again. You know? Specialization only works when you like have a generic implementation for T, but for I32 it's like specialized. It's similar, but it's different. Because it's basically like from the user point, the user who is trying to get like I32 as foo, right? When you do this specific operation to get the implementation of that trait, you are expecting this to be got from a specific, from like once again from this global map, right? Yo, making my own language too. What does the syntax look like and what does it compile to? Right now, I have only interpreter. I will have the compilation later. The language is supposed to have compile time evaluation similar to Zig, which means that it's required to have an interpreter anyway. So we start with interpreter. Right now, it doesn't compile to anything. The syntax is also looking like whatever you want because we have extensible syntax, but their standard syntax looks like this, I guess. There we go. This is an example of guessing a number. I don't know. It's not much different than Rust, maybe. It's not object-oriented. It's we can say multi-paradigm programming language, but the important thing that makes it like some of the important things I already said in extensible syntax, but that's like doesn't really matter much, I think. There is compile time evaluation, so during compilation you can invoke any code, and then it is a context-aware programming language, which means that if you have a thing, what's unwindable? Yeah, 1 second. I'll tell you. So context-aware programming means that your functions are aware of the context in which they are being ran, right? So, for example, in order to do printing hello world, this doesn't just work always. You can only use this standard print function in a context which allows you to like write something. So the standard print is a function, and its signature is that it takes a string, it returns nothing, but it requires a context which specifies the writing like semantics. It doesn't necessarily print to the standard output. It can write anywhere. It depends on the context. So like it's context aware, and this is also supposed to be like checked at compile time whether or not the context is properly supplied. It's similar to the algebraic effect system, basically, if you have heard of that. The unwindable means that we can unwind the block. So we basically, unwindable means that I have the ability to go out of the scope. So think of unwindable something as returning from a function. When you use a return statement in a programming language like C, you basically you stop executing the function. You unwind the stack to where the function was called from, right? And like it's basically like go to outside of the function. That's what it is, right? But unwindable in general is like it's not specific to functions. It just is an unwindable scope. So from inside the scope, I can exit the scope whenever I want. It's not limited to functions, basically. And also like this unwindable block, it gives me a token. Right now, that's how it's implemented, and I use that token to like go back out of that scope. And specifically, this token is being used to quit out of this block over here from inside of this function. So this function knows how to quit from this block, basically. So like this way, you can implement returning from inner functions Returning from inner functions is a feature that you don't see very often too, but like, for example, you can do it in Kotlin. Return from inner function, I think, right? Returns and jumps. Like in Kotlin language, you can have a labeled return. You see, return lit, right? Local return to the caller of the lambda. Like, it's kind of similar. So like this creates like a tag and you go back to that tag, I think. Maybe not exactly what it is. Return for each local return to the caller of the lambda. So like you decide where to return, not just from the current function, because this is like the anonymous function in lambda that they create here. So yeah, something like that. Yeah, there is like a more powerful version of the unwindable block, which I don't have implemented yet. But we also are supposed to be able to like pause the current execution of a block and then resume it later. So that feature, I don't think I had it implemented in this version in the Rust. In the previous implementation in OCaml it was working though, which is called like delimited continuations. So it's very similar to this unwindable block, but basically what you can do is that you can go like outside of that block and then back inside to where you like quitted from, you know, kind of thing. It's kind of not super simple to explain, I guess, without a concrete example. But the specific example would be something like async await. When you like await something inside a function that is async, you technically pause the execution of the current function, go somewhere else, and then at some point you come back when like the thing that you were awaiting has completed, right? So that's what it means. Do I have any docs? The language is in the works right now. I have a website, but it's not really docs, and it's a little bit outdated right now. What's your language that you're making? There's a playground, but once again, not really much docs. Here's a hello world. But yeah, it is an interpreted programming language, but it's supposed to be compilable, so like all the types needs to be done. If I say something like dbg123, for example, here, it will say that the number literal type could not be inferred. It's trying to run the inference algorithm here, but like 123, I don't have any default number type, so unless I specify this to be an integer, it's not going to actually work like this. This prints 123. So like inference is also there. And the type system. Right now I'm trying to improve my inference by having subtypes, which I didn't have before. But I think the short version how I explain my language should be something like it's basically like Rust, but with an effect system and a comp time. Maybe that's the best explanation, like the shortest one. I don't know. I don't want to go here. Yeah, I was talking about like these maps. Yeah, whatever. Yeah, I wanted to like have the cache so that I don't test the things multiple times. So I need like a different equality operator. R2D2. I think I saw this. Wait, what? Hold on. I think I actually saw this language, but I'm not sure. I don't remember where. Maybe you showed it on like the programming languages subreddit or something. You have a lot of documentation. Type system. Cache, clean, syntax. Error handling, built-in result type for explicit error handling. That site is all ChatGPT? Ah, okay. Built-in support for async. You have result types. You can sign function with type inference. All right. Sure. Higher order functions. Nice. Do you have higher kind of types? You have HKT. You have module console logger implements logger. Why is it called module? Because it's a zero size struct basically. It's automatically creating a zero size struct. Sure. Why not? Can you have inside the interfaces? Can you have types, or can you only have functions? Can you have a type inside an interface? Can you have another interface inside the interface? So it's like a JavaScript interface. It's like, so this interface is like in the a TypeScript interface. Okay. Probably. Overview. IO and system. Page not found. Amazing. Page not found. Then patterns. Why? Save by design, built-in error handling, null safety, and strong type system help prevent common programming mistakes. Here's a question for you. Save by design. You compile to native code. You have like unsafe, like in Rust, to escape the safety, which is by design. So you can escape the safety and write some built-in, some like inline assembly potentially. How do you have integer types when compiling to JavaScript? Well, I mean, for the sake of the type system, you can have it as like it's all like JavaScript. It's only JavaScript in like it's only like a number and not only an integer in JavaScript, right? But I don't know, like it can be just an integer in the type system. Like it's the same as the like how can you have integer types when you're compiling to like assembly? Because assembly also doesn't have types, right? We only have memory and like, but you don't have any like specification of what actually sits in the memory. You just have like the operations that work on that memory, and only when you like do a specific operation, only then it matters. So yeah. So here's like I was telling about the context system, right? This is function context, right? So one example would be like of the context system is something like an allocator. One example would be unsafe. So like if I have some unsafe operations, I can require the function to only work inside the unsafe context. But context is like a more general approach. Like if something needs an allocator, then we need to have the allocator inside the context. If I am like adding numbers together, then there can be something bad that's happening, which is overflowing. So we can define the behavior on that with context system and I guess other things. So basically what a function can do can be specified in the type signature, which improves the safety even further. Like one example would be panic, right? I sometimes really want to guarantee that my code doesn't panic by just not having it in the type signature. Town. All right. Let's close this. When it comes to syntax, do you have any tips? What do you mean tips? To what is the better syntax? I don't know. The syntax is kind of like very subjective. My syntax is extensible, so I can like I can have a user specify their own syntax. It's working through a macro system like in Lisp. But my personal taste is, I guess, something what I am making. Although I might change some of the syntaxes. I don't know. Like one of the things that I don't like is okay, personal taste. I think most important thing is white space sensitivity. Do you want to be white space sensitive or not? Right? Like in Python, you can. Like indentation matters. I don't like that. I want to be able to write everything in one line and then like the formatter automatically converts that to the things. This means that I have semicolons because to split the instructions. Other than that, it should be just making sense. I don't know. The syntax is the thing that matters the least, I think. Syntax doesn't matter much. Need to implement the LSP. I don't know. What are you making your language in? There is a. I know that there are crates for Rust. Implementing LSP. I have not gone there yet. No. But I have been told that you just read the specification and it's like. Not difficult to understand. There's this specification, right? So yeah, first thing is to understand what the language server should be able to do. I have not looked at that yet. But there are some crates in Rust, for example, that allow that to be made easier. Chomsky, maybe? Is that the one? Parser library for Rust that makes writing... Oh, is this just for the parser? I don't know. I have not researched that much yet. Golang. I don't know. I will implement it from scratch without any libraries. I don't know how, but I will figure it out. I start by making my own programming language, but I have no idea how to make them. I'm just like figuring it out as I go. Most of it is not that difficult, actually, I think. The difficult part is figuring out what you want from a language, I guess. So that's the difficult part sometimes. So it helps if you have tried like 100 different languages to know what is there already, at least. It's pretty easy to handle basic requests and provide errors. Yeah, I think so. Like I already have all the type information for all, like, and with spans attached. I think like if there is like in the API a request like what is the type of a thing under the cursor, I can do that already. Like I just need to connect it with the API. But I kind of already have that information, right? I guess like the difficult part is making it incremental and not like recompile everything from scratch every time, right? But I think the easiest way to implement the language server would be to just run the compiler, get the information from the compiler, and yeah. And then just answer with that information. Incremental is difficult, I agree. My personal stance is that one, all adjacent white space can be represented by a single token. White space between expressions is significant. White space adjacent to punctuation is sparse with the operator token. No other white space is significant. I like this idea, Spike, technically. Right now I don't have it, but maybe it's not a bad idea. The only problem is like how do you write your negation, for example, right? And like a reference to X. So a reference to X and a reference space X would be treated differently because it would be a different operator. In one of them it's a reference space, in one of them it's just this, and same with negation. Space here and space here like means different things. Maybe like for some of them you need to treat both of them the same way, and but for some operators it would be like different. I don't know. One question: how you figure out what you need for your language? Do you create a program game in parallel, or just look at other languages and implement the same features? Well, I have a goal in mind, right? I do want to make games with the language. I know what I am missing from Rust, which I'm currently using to make the games. So I know what I want. I've seen some parts of what I want in other programming languages, but none of the languages have like combined all of those features together. And then I don't know, maybe we have even some more features that I have not seen anywhere yet. I don't know. Yeah, the token decides if it cares. It could have a catch all if there aren't two left, right, or both. Yeah. Okay. Here's another example, by the way, Spike. Here's the problem. When you have double operators, like a reference to X, right? Something like this. Reference to 1 to 3. Like this. Should this be a single operator? An end. Right now I'm treating these as two separate tokens. But yeah. My rules are not like very thing. I think I'm doing right now in my Lexer specific tokens, specific characters are a single character tokens, but otherwise all the punctuation is like a single token. So for example, plus plus would be a single token plus plus, right? And like plus 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 is another token. But yeah, I don't know. What I mean is like when you have an operator and then another operator, like a unary operator. I don't know. I mean, it's weird. It's weird. I don't want to think too much about the syntax because, like, once again, I think it's not the important part of the language. Are you going to have function overloading? Probably not. Probably not function overloading, but I will have the trait system like in Rust and like the type classes, which allow you to have polymorphic functions. I don't know. I'll think about function overloading specifically, but it's not super necessary. The problem is that, like, function overloading means that you actually have multiple, like, values, multiple functions associated with the same name, right? But when I say let function f be like this, like, my functions are just values, which I which I store in variables, just like something, just like other things. So if I had function overloading, this means that this single value should be corresponding. This single variable should be corresponding to multiple values, so that I can have the overloading. So instead of that, instead of overloading, we have polymorphic functions, which means that they should work for all different types of arguments. So like we have the argument, which is like it's like generics, right? So this is the arguments of the function, and then I have the like the argument of this type, right? And then I'm printing hello. Let's just do this. I need that. There we go. So in this case, because this is a generic thing, I can call the function f with like 2 arguments, or I can call it with 1 argument. The like you do it in this way instead, you know, instead of actually overloading. Does that make sense? And then like this is basically automatically inferring what args is when you call the function with the type inference, right? Then inside of here you can also like inspect what the arguments are and make the decisions based on that, like by running some code at compile time. I think like the only thing that is missing from Zig is like the inference that works like in the other direction, so that like Zig can do this, but you need to specify this explicitly. Like for example, over here, my argument is the type int32, right? Like this is the full specification of how I call this function. My argument is an int32, so this one is int32, right? But this can be inferred automatically. Yeah, and I mean right now I cannot put constraints on the args, but I'm supposed to, yes. The language is not fully implemented yet. So I should be able to put constraints, but also I want to be able to just run some compile time logic based on the arguments. So it's like instead of the constraints, it would be, I guess, like right now it's more similar to C++'s templates, I guess, than to like proper generics without the constraints. But yeah, constraints are also like important. Not there yet. Right, I've been working on something. It's nice talking about the language, but we also need to implement it sometime, you know? Okay, we overflow the stack. Yeah, I remember. We overflow the stack because over here I need a cache. So I think I need like a trait similar to equality, but a different one. For the sake of inference. So what does this mean exactly? I want something that is like I want equality that doesn't look into the actual values of the variables. So when we see 2 variables, I only treat them to be the same if they are the same variable, not if their value is the same, right? So how would I call this trait? I don't even know. I kind of like, okay, I mean, I can just use the normal equality, but the problem is, once again, that in my actual language, because I'm using a type, which is an inference variable inside the type shape, maybe this should be a generic thing, which specifies the type there. But then I will need to be able to convert between the things. Like what I need is this trait. I need the equality and hash to be a different type of equality and a different type of hash. Trait. Same. We can call it same. Same for the sake of inference. So that's why it lives in the inference, right? So we have a function is same, self, and other self boolean, right? That's what I want. And since I want this to be inside of a like the hash map based on this equality, like should this also have the hash inside? It's kind of weird. It's kind of weird. But I mean, I can do that, yes. Hash self it's the hash for with same the same. So I would have like like a new type here, which would like override the actual hashing for this, which will like use the this implementation for the hash instead of the t's implementation for the hash, right? I think. So over here, I say save 0 hash, specifically t as same hash self 0 state. So hash mute input std hash, right? Something like this. Wait, this doesn't work? What do you mean? Syntax error. What do you mean in syntax error? Expected 3 arguments? What is this icon? The impl? Wait, you cannot do that? Inside the, you cannot have impl trait as an argument of a trait? I thought we can do that. You didn't. Wait, what? Oh, I need to name this thing. That's it. Sure. State. There you go. I'm stupid. No, I'm stupid. It's working. It's working. I just forgot to name the things. I kind of don't really like the fact that I need to specify the name of the arguments in a trait because, like, this name is not needed here. Kind of. I mean, sometimes I want that, but sometimes I don't. Oh, it's a hasher, not a hash. There you go. And then we also implement Oh no, my Rust analyzer is panicking. Something out of bounds. Shit. Rust analyzer, please restart. So then we also implement partial ec for this. So this would be self 0 t as same is same self 0 and other 0. Hello Tenet, by the way. I don't like this naming, but I don't know what is the better name for it. So we need equality and hash. I need proper equality, right? Impl t. Wait, it still is panicking, even though I restarted it. What happens? My rest analyzer is panicking. Index out of bounds. It also makes me like wait every time I type a character. The length is 2, but the index is 2. Stupid Rust analyzer. To have this, these 3 traits are necessary for me to use a hash map, basically. That's it. So now we have the state of the inference, right? So we have struct context, the inference context, which right now has been just like a global thing. But in context, we have the cache, like let's say sub set cache. It's going to be a hash set of like pairs that subset cache key. I'll name this thing subset cache key. So subset is it's with same t, and superset is with same t, and then we derive partial ec, and hash. So this is generic context. I don't want this to be generic. I think I will use the AnyMap here. And then we, for context, we'll have something like function subset cache for t, which is inferable, because I can like infer multiple different types. And this would give me a hash set of a subset cache key of type t. So, and import Okay, so this would be self subset cache dot get no dot entry or default. There we go. Talking about t same. Yeah, so inferables now need to specify how to see if they are same things or not. Okay. Okay, sure. Can I borrow this as mutable? Yep. But... So I think for now, though, I will do something like static context. If I didn't use a static context, I would need to like specify it everywhere, right? So like a new variable should be made inside a context, right? And things like that. But that's unsafe. No, we can do a safe global context with a mutex. We don't need unsafe. But like I think I do want actually to have not a global context, but a context which I can save like snapshots from. Like I already had this before in my previous inference engine. We had like it was done with a global context, but it was a little bit cursed, you know. It was a little bit cursed. So have the global state, and the global state I could make a snapshot of the global state, and I can revert it. So like yeah, there you go. That's how it works. So like I just have a state, which is a global mutex, right, of the actual state. Which things are inferable? I thought only types. No, not only types. You can infer the values too. So in Rust you have const generics. So when you use const generics, you can infer generic values, right? You can infer constants. So that means that you don't only infer the types, you also infer values. You also infer lifetimes. You also infer, in my language, the contexts, the effects, right? Maybe some other examples. I don't know. But like value is not a type, right? Like if you want to infer an integer, because you have the integer as part of the generic, as like a generic argument of like an array type, right? Or a fixed sized array, then you want that to be inferred too, right? You could make enum from all inferable types instead of generic. Yeah, but why would I want that? It's like I should like I think it's much nicer to just have the inference engine be independent of what I actually have in the language. So like this inference engine is completely its own thing, and it should be usable. Like if you want, you should be able to use this in like your own language for something that's not cast. Why? Because why not, you know? You just implement the trait for your thing that you want to be inferring, and that's it. And then you just use it. But I mean, yeah, you can use enums instead of traits for a lot of things, sure. And you can use traits instead of enums if you want it to be more extensible. Both have their advantages and disadvantages. Sometimes I kind of wish it was like really easy to like if at some point like you're a trait hater, right? But traits like I mean technically traits make it faster. With an enum, you will need to have some sort of the dispatch at runtime based on the actual thing, right? Also like you say you are a trait hater, but it actually is the better interface, because when I say over here infer as a value of this type, right, this means that if I had an enum, right, enum, which is like, I don't know, value, like I don't know, I want to be inferring ints, like, or constants, right? Let's say const or type, right? So it's either a constant or a type, right? It means that like should I be able to infer a constant as a type? No, I should not. That should never happen. So like this is an operation that always fails. So the API is like easier to misuse basically. because of the using enums instead of like you can have enums for every single type in existence, you know, and then you just get yourself a dynamically typed language. How many features from Java am I going to add in? Well, there is at least one, the checked exceptions. I'm not really sure about the object orientation and like inheritance yet, but I'll think about it. There are some use cases where it's kind of nice, I guess. Not sure what to have. What's a good example though? But I'm pretty sure there are some use cases for it, right? Okay. Trait var t same is not satisfied. Okay, so we implement the inferable same for var t. So since a variable is basically just a reference type, is it the same as the other variable is based on the arc, right? So since I'm storing literally an arc there, this is the pointer to the actual data of the variable. So we just do arc is pointer equal. Are the pointers equal of the self data and other data? That's all that I need here. And then hash would be actually hashing the pointer itself, right? So self data. So I don't hash the data itself. I hash the pointer arc as pointer, right? And then this thing I actually hash. I hash the pointer into the hasher. There you go, like this. That's what we do for the variables. And then for the tests here, I need to... so I kind of want to be able to derive it then. It's like, it's really same as the partial equality and hash. Sure, let's just have a derive create here to cast inference derive. Sure, let's do that. Cast inference derive dependencies. Cast inference derive path is derive. All right, so we derive the same with attributes. I don't think I do any attributes. This is where, I mean, okay, this is going to be weird, but sure. Okay, so we do that. Same rate is inference same, past inference same. Field to try new name. I don't need new name. Fields. I think I don't need that. Let's start with a struct. Yeah, so we implement the same trait for this thing. So for that, I'm going to do the hash, which takes mutable impulse to the hasher. I do not have a result here. I just do this. And then we just hash fields, field names, like that. Okay. Field names is data fields iterate map field field ident collect to vec, and then hash fields is data fields iterate map field. So this is how I hash the thing. How to hash the thing? I say quote I don't need this here. Yeah, I just say quote self dot identifier dot city hash hash. No, not hash. Not hash. Not hash. And to do same trait hash self ident hasher like this. Hash fields, this needs to be repeated. So field names are not necessary here, kind of. This needs hashtag. All right. And then we also have function is same self other self and boolean. So this would be just for no, not for is same fields, just like that. And then we return we return true. Check same fields. So check same fields would be if not same trait is same self dot. This is not the correct identifier. This should be like field. So field is field ident. I also hate this. I hate this in sin. Like I need sometimes like I want this to work also for like unnamed fields, but this is optional. Declarative macros are way easier to make. Yeah, but like these are easier to use. It's not that difficult. I mean I hate how this works, but I mean you just tried it once anyway. We've been experimenting on doing macro rules that have derived macros. So far results are not looking that good. It's still super unintuitive yet. One thing I don't like about the macros, they always are in the root of your RAID. They're not respecting modules, among other things. Yeah, I don't know. This is kind of relatively simple. I think what I don't like here, actually, like this is like if I want to, when I want to have a derives for in my own language, like I will want to have derives too, right? Did you guys see this crate? Hold on. Faced. Did you see this? Let's take a look. So this thing, faced provides const fn reflection for Rust. create faced shape is a static shape. So I think what it does, it gives you the shape of the type as a compile time thing, right? It's literally a const, so you can use it in const contexts. So you can, in a create you derive, you do derive code using the heavy scene, right? That's what we are doing right now. Faced derives data with the light and fast unseen. I think this is actually probably like I think this is basically close to compile time, like actual reflection. I didn't look much. The last time I looked there, documentation was bad. But let me see. So the shape associated constant fully describes a type, whether it's a struct, enum, or a scalar. All fields, memory layouts, vtable for various standard traits. Okay. Use case. So it's like compile time, type inspection. And I think they have like the example of basically implementing the deserialization instead of SERDI. You just use faced JSON, right? So you derive only a single thing. This thing is what allows compile time to see the definition of this thing, right? We can build it fully through reflection using the slot-based initialization API. What is that? Foobar, whip a lock with field. Ooh. Oh, and you can also materialize it, so you can do it with like runtime reflection too. Field named. The reflection API maintains type safety by validating types in each steps and tracks which fields have been initialized. Oh, so that's how you like do it with like deserialization. I see. I think I understand this. So you have like this builder pattern to build the value, which looks like you're building like just a normal like dynamic object like in JavaScript, but then it actually is checking that the field exists, that the type that you are providing here is the type, the actual type of the field, right? When does the check happen though? It's not really happening at compile time in this case, is it? This approach is particularly powerful for deserializers when you need to incrementally build objects without knowing their full structure up front. Inside a deserializer, you would first inspect the shape to understand its structure, and then systematically initialize each field. Use case, parsing CLI arguments. I think this is nice. It is a new thing. Nothing here is comp time. Well, the comp time is the type info. I think the like so since this is a constant though, I think the problem is that you cannot use the constant because it's behind a trait maybe. Or can you? Can you do this? Trait foo. Const I32. Const C I32. Impl foo for I32. Const C 32 is 1, 2, 3. Const fn foo. Can I do inside of the constant function here something like I32 as foo C, right? I think it's just limited by what can Rust do at comp time maybe. Because like you can access this inside the compile function, right? You just you cannot use the prints. I32. But you can do this inside of the const function, right? dbg foo, right? So like this is a constant. You can use it inside const fn thing. But I think what you cannot do is you cannot make this generic over foo, right? And then you say t as foo c, right? So dbg foo I32. This is not possible right now, I think. Wait, it is. Wait, it is possible. You can have generics. I thought you cannot do this in Rust. Is this new? Maybe I cannot call another generic function. Goo. Maybe I cannot do this. Goo t. Wait, I can. Okay. What can I not do in const functions in Rust right now? Can I iterate over like a list? We can see this. This is a static shape, right? This is just a type from the faced thing. What's a shape? Only while loops. Type shape. How do I go to this? Where is the shape? Shape. So you have this thing that is existing at compile time. You have you have this thing. Okay. Let me see. Let me try this. If I have struct paste, right? Attributes is static list of integers. How about this? We do that. So we constant is of type faced, right? So we have this here faced, and this would be like 1, 2, 3, 4, 5, 6. Can I do that? So then over here I would need to do like iterate, copy it some. Can I do like maybe like this is something that I cannot do, right? C.attrs, something like that. Cannot call non-const method slice iterate, right? So this is something I cannot do. Can I do a for attr in this attributes 0? Mismatched types. Expected, yeah. This is fixed. Attributes is that. That's what you want. Cannot use for loop on reference to I32 in constant functions, yeah. All right. So it's just like because of the limitations of the const functions, but otherwise I think you would be able to do some more stuff if you have like the type definition like this available for you at compile time. You should be able to iterate over this and do something with it. I mean, I guess you cannot really generate code though. Right? Like you cannot generate code. If you iterate on this at runtime, is not really the same as generating code. So I guess what's missing in Rust would be like, since this is available, we just want this to go into as an input of a proc macro. That's what we want. All right. I mean, but even like having this type information available at compile time is already really nice, I think. So like they already have serialization and a bunch of other things done with this. So you derive only one thing instead of deriving 10 different things, and the other things are working based on that information. So like what I imagine is basically having this type information available at comp time, like natively. That's literally how it works in Zig, right? You can just Zig, you can just have the type of a thing, and then it gives you the type which you can inspect at compile time easily, right? But even then, still, once I have the type information, the code would still look the same, right? We would still want to generate some code with something similar to quoting. I literally have quoting right now already. I can generate code. So this thing would kind of look the same, I think. The only difference is that this is based on tokens, but my quoting is based on, like, ASTs. But it will still look the same, I think. I don't know. I guess the examples to look at how other languages do it is like, how does Haskell custom derive? How does deriving work in Haskell? Because like I think they work like they give you this. Derive is a tool for Haskell to let you write your own deriving mechanism. HC used to provide a derivable type class extension called generic classes, but that was rarely used. Somewhat weak. Derive. Data derived library, a tool for deriving instance for Haskell programs. Work with custom derivation. Sim and template Haskell mechanism. There are examples. Using template Haskell derivations. What is this? Derive make egg color. Make binary color. Why is this in a separate thing? Because it's a template Haskell? No, that's a different thing. I thought you would put it inside the deriving list here. Just like in Rust. Let's imagine we've defined a data type like this. Now we wish to extend this type to derive binary and change to defining ACK using our library. To do this, we simply add the deriving clause. But why is there a dedicated syntax for it? Because like this is built-in deriver and this is not built-in deriver? I don't know, weird. What's a good language to look at which does this thing well? Field. Alright, so I want to check the same fields. Field is field identifier. That's what I wanted. Hold on. That's the reason I think. Name, scene member. There you go, there you go, there you go. I think I need this. Here too. Do I have fields? So this allows me to have the field accessed by index, right? So that's why we over here we enumerate. In case the field is unnamed, we get it by index. There you go. Other things we don't care about yet. Is there something, but couldn't find it again. It was something like sorted for proc macros, like using derive to make a deserializable params, make the code generation simpler. Because you can create separate structs for enums, structs with named ones. I'm using Darling myself sometimes. Am I using Darling in this project? Darling, oh, I'm not. Maybe that's the one that you're talking about. I don't think it. Maybe it would help me. You hate Darling? Which one is better than Darling? Down. So when you're writing your proc macro, you can derive the thing which parses your proc macro input, right? Which is like your struct into the actually like structured data, right? What is your type? What is your generics? What's the actual data? And you have like your fields there. And for every field, I want to I want to have like these attributes, so it automatically parses all the attributes for me and shit. By hand is better per project? No, I don't think by hand is better. Like especially when you have a bunch of attributes, parsing these attributes is pain yourself, I think. If you don't have any attributes, I think it's not that difficult, so I'm not using it here because I barely have any attributes. But yeah. Darling ruined my internship codebase. Like over here, you see how over here I'm doing basically the same thing as Darling would do, but I literally copy pasted this code. So in order to know for every field, how can I refer to this field, I need to write this much code already, right? So yeah, because sin by itself does not give me this information, right? Sin just says that the field either has an identifier or it doesn't have, and if it doesn't have the identifier, I don't know how to call it by index, right? I need this member, right? It's either a named or an unnamed field of a struct. So like I need to parse this myself. Why is this not inside a library somewhere? Like, I cannot just have a field from sin and get, like, how do I, you know, like, sin member. No, not sin member, sin field, like this thing, right? Sin field. This thing, I cannot just refer to it. Like, over here, when I'm deriving some code, I want to be able to, like, call this. Your own function or extension trace, you really want to do such a thing? Yeah, but I will end up with something like Darling myself, I think. Eventually. If I start doing that. Down, 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 down. You cannot even do an extension trade because like I have a field here, but like I don't have I don't know what's the index of this field, so I cannot even like generate code that uses the field. It's annoying. So instead we have this function fields from data fields, and only then I map the field. and this is a name, right? Field name. That was the problem I saw with Darling, is that people try to use it, but they really need something slightly different. The second you need some custom code in the middle of a larger Darling feature, you have to write it yourself anyway. I don't know. I think I had it working well enough for me. Fields, data fields, dot map, field name, and here we use field name. There you go. So if it's not the same tray, the same thing, self field name and other field name, in this case we return false, so we are not the same. And this is the code that we repeat over here. Okay, there we go. That's it. So now I can do this for enum too, easily. All right. Down. So this thing here should be check same variant, and this should be hash variant. I will match self, and this is inside, and this is also match self other. Check same variants, and then if it's any other variants, then I return false. Check same variants. And like this. So what is hash variance? Check same variance is data variance iterate map variant. So for every variant we have I feel like also like this code that I'm writing here can be like I'm duplicating code again between like the enum and the thing and the struct. It's annoying. Why can you not come from format even? Cargo FMT, hello? Why does it not format? This is annoying also. Like, I think this is the most annoying actually thing when I'm writing proc macros. It just doesn't want to format my code. Even although it's like it's really easy to abstract prematurely in proc macros. Yeah. Sure. But then like you end up doing this every time, which is annoying. Like I'm spending time here, which I should not be spending. And this is also annoying. Okay, it's actually going to be a little different here. That's why I was matching, by the way, before, because that makes it more like in line with oh my god, this is okay. This is why I was doing this. Look at this here. We have name inside a field and we have a new name, right? So because I want to generate code something like this, you know. I want to like I will match self, right? And if it's self some variant, and this variant has unnamed fields, right? It has a named field, field 0, and then field 1, right? I need to actually generate the names for these fields, and to actually generate the names for these fields. So that's what I'm doing here. Okay, I actually need this. It's annoying. Kind of. What's annoying is that I cannot just use a 0 as an identifier. If I do an R0, this doesn't work. So let's copy paste this thing too. Not really specific. So the only thing in this try hash, like do try, this is the actually like if I have the attribute, yeah. But if outside of the attributes, it's the same thing, name and new name. Underscore 0 is pretty common. I do underscore self underscore 0 here. That's what I'm generating. But like even to generate underscore 0, you still need to like generate. And also like this can potentially collide with some of the existing names. Potentially. So like because this span should be technically the definition side span, or like something like yeah, the macro hygiene here is also a problem when you generate these names. I was doing something with macro hygiene in cast. I'm not sure if it's like working very well right now or not. I don't remember, but I was doing something. Okay, so basically over here I'm going to quote self colon variant name, and over here we do field names, I'm bind field names to field new names, right? That's what I do. And then I also do, oh shit, and then I need to generate like 2 different names. This is so annoying because I'm trying to like match two enums if they are the same, right? So then I do another variant name, and over here I have field names. So I need a distinct identifier for each field. Field new names 2. So annoying. I guess technically I can generate this not in as a field, but like since I have the member, I can generate it inside, have a helper method, something. Anyway, so over here inside we do check same fields. So what is field names? Field names is fields variant fields dot map field name, field new names is fields variant. I mean, technically, I can like generate my own things here. It's kind of simply. So what you suggest is I generate this in place, like this. So I map every field. I just always enumerate them basically. Because I don't really care about their names here, right? So variant fields iterate. Enumerate map Index. Don't care about the actual field here. And then I just do sin ident new. And over here I format something and then span. I use the same span, yeah, field. We do field span. Is that what I do in this case? So then I do underscore self index, right? And then for the other one, I hate that it doesn't format. Why does it not format? Hate this. Let's call this field self names and this field other names. Other index, there you go. So this, we bind this to self names, and I bind this to field other names. Like that. Format ident exists in sin. Where? I don't see it. Format ident not found. Quote. Hygiene. The span of the first ident argument is used at the span. But what is the type of this? What does this return? What does this macro return? Does it return actually the sin ident, or does it return the tokens? The token? Because the quote macro just returns the tokens, right? So it's literally the same thing then? Just format ident. Like this. And what's the span then? So like by default it's just using some span. Unexpected one of these. Unexpected argument number 2 in proc macro 2 ident. It's proc macro 2 ident, not sin ident. But I guess it doesn't really matter, maybe. Maybe it's the same thing. To remove the extra argument. What do you mean? It must be passed? So like, is it like the extra thing? Or do you mean like, we pass it as an argument to the ident? Is that what you mean? We create the ident using format ident? Is that it? That's how I use it? My ident, format ident, my ident is ident. Oh. Wait, there is a colon O. Okay, wait, hold on. It doesn't support the inline names, that's why, right? It does support inline names, that's it, probably. I was probably doing it correctly. So we just do format ident self, but then the index should be passed here. Is that it? That's how it works? I think this worked. Never used it before. Don't use thing. Can't get span from inline names. Is it like getting the span of this argument? Is that why? So the span is the span that is inside of this proc macro? Is that what we're going to get? Interesting. But I can probably like specify the span manually, right? Yeah, span is my span. Yeah, I can do this too. If I want the error messages to be pointing to the correct directions. Down, down. Why do you decide to make a new language? Is it for better understanding that will help you at work? Nah, I don't think this will help my work at all. In fact, it will hurt my work because I will hate the language that we use at work even more. Like, I don't hate it enough. That's the biggest issue with like Rust. I mean, we can complain about Rust all day, but it's still like the nicest languages of all that I've worked with. So learning Rust was actually a mistake because it made it harder to work in other languages for sure. So if I make something that is even better, then I will not be able to come back to Rust. Similarly, but yeah, I'm just making my language for fun mostly, but there is definitely, I think, a lot of potential in this. I just don't know if I can do it myself. There probably there's a lot of languages that are being created right now. Some of the ideas that I have, other people are also doing them. So I don't know if I will actually finish the project, or maybe I will just see that someone else has finally created the language that I want, so that I can use that instead. You're getting hyped about cast? Yeah, but like it's it's very slow, the progress anyway. I'm kind of hyped about it, but there's a lot of work to do. Cannot find variant name. Okay. Variant name is variant dot identifier with a reference. Now what? The trade bound map impl iterator item field closure to tokens is not satisfied. Of course. Of course. This needs to be repeated. Trade bound mappable iterator. 2 tokens is not satisfied. The full name of the type has been written to over there. 61. 61, this thing. Field names. Field names cannot be serialized. Wait, what? Why not? Hold on. Field names. Field names is only being used over here. It's used inside of a repetition. Oh, wait, hold on. I did not do the repetition over here. This thing needs a star. There you go. Okay, so this is the implementation of the variant. And then we need to do the same, but with hashing. How long did I spend on making this proc macro already? Hash variants. Hash fields. So for hashing fields, we just do that. Um, field name. I think even without a reference, because we're going to match, we create the field names. So I think we just do here field names, create map field name, like that. These things I need to collect then. Back. So this would be I need field self name, so never mind. This is not needed to be collected. I mean, I can collect it, but it is not needed. This thing it's because over here I need to do field self names. Hello, Nigel. This field is not used. Field other names is not needed. Hash fields is that. Variant name is this. So I just match a single thing. Like this. And inside over there, we just hash all the fields. There you go. All right, now I use a moved value field names. Sure, collect, vec. Can it return reference to local thing? Field names. I guess if I don't collect, then it's fine. No. Fine, we just clone it here. Fields. But why can I not reference it? Actually, it's weird. Because this is a temporary. Is that why? Whatever. Clone. You're wasting finding in Factorio instead of contributing. Nigel was contributing. How's it going, Nigel? Are you going to finish the thing that you were doing? Expected value found self. Failed to resolve. Self is only available. This is not saved file. All right, okay. I think this works. So now I can derive this. I just need to re-export this from here, right? I need to pub use cast inference derive star. Okay. So now inside the test, let's try this. So I want for this to derive same. And similarly for this, I want to derive same. Expected unit because of the return type found a result. Okay. Do I return OK somewhere? Yeah, this OK is not needed. There you go. Expected nothing found result. Probably because I do it the same in the struct. There you go. Okay, so now the same is not implemented for I32. Here's what where specialization would be nice. So now I need to implement this trait for with this trait for everything that I want. Same. Yeah. This is where I will use macro rules. Impl for full same for type type split with a comma with a trailing comma potentially. So then we do something like this. We do implement same for type. Function is same self self boolean. So this will just use the normal equality. Self is equal to other. And then we do this. Okay. And I just do std hash self state. So this is implement implement. I don't know what's the good name for it again. So I just implement same for. There's a lot of implementations that I want. Yes, let's just do U8, U16, U32, U64. Let's do this. What else? Use size. Size. Right. I mean, I can always add more later, but this already compiles. So now, let's assume that this all works. This was a lot of work. And now I was going to do the hash, right? So we have the context. We have the context here. We have the subset cache. If we already checked it or not, right? So whenever I say that the variable must be a subset of something over here, or maybe variable, I think, right? If I already tried this, I just do here, I infer same myself. But in order to infer this inside this crate myself, I need to say what is cast inference. So I will say use crate as cast inference. Is there a better way to like refer to the crate in which the trait resides in my derived macros? I don't know. But I want to use this inside the crate where the trait itself is. No field 0 on maybe var t unknown field. Wait, hold on a second. So this is an enum with unnamed fields. Okay, what's happening there? No field 0 on maybe var t. Let's see. Match self. Oh. I mean, yeah. Wait, what's the problem? Self-variant name, self-variant name. Wait, what's the problem? No field 0 on type, maybe var t. Self dot. Oh, okay. Over here, I did it wrong way. Because this should not be field name inside the variant, right? This should use these fields, right? Yeah, I should actually use field self names, iterate, and then zip that with field other names. So this would be field self name and field other name. So instead of self dot field name, we use field self name, and instead of this, we use field other name. I don't need a reference because they are already references. And then this is going to be like moved. So I need to collect back both of these, I guess. All right. We still overflow the stack because I'm not using this yet. Once again. So over here, right? When I infer as a subset of, now I want the context. I still kind of like this API, but like the context needs to be passed here as an explicit argument, or I can just do the same with global context. Just do a global context again. I don't know. I think it's easier to do it like that. Context, one slok, mutex of a context, and like so. Dean any static cannot be sent between the threads safely. Wait, wasn't I using the same thing? Oh, any map 3 map like this. Okay. This is weird. Not just any map, but any map with clone any, send, and sync. So this means that T, which is inferable, must also be send and sync. And it bound hash set clone is not satisfied. Fade map subset cache key, because this thing should be clonable with same derive clone. And then context default is not specified. Over here we just derive default. Okay, there we go. So now I have the context. Impl context. Function. What did you miss? How's the white paper impl progressing? Slowly. Maybe I will have it soon. See. Yet. Book. Card. When you look at mutex card, right? This one. Mutex card. Context. Self. Two. Like so. Cannot find mutex card. I mean, can you import this? Or qualify? Sure. Okay, so over here, this is it finally. So we have context get dot subset cache dot no dot subset cache function subset cache which gives me a subset cache key, right? Insert the key self clone subset cache key, where subset is self clone and superset is superset clone downtown. Try wrapping expression with same. Can you do this as a code action, please, so that I don't need to do this myself? Trade bound, maybe var hash is not satisfied. It should not be hash. It should not be hash. Trade hash is not satisfied for maybe var. The trade hash is implemented for subset cache key. Unsatisfied trade bound introducing this derived macro. Source lib11 over here. Yeah, this is also annoying. So when you derive things like clone, this automatically when generates the code impl t clone for this struct of mine. But I want to implement clone without this, which means that I need to actually implement this myself. Can I convert to manual? Yeah, let's do this. So like I convert this to a manual one, but I don't need t to be hash. There you go. Annoying. And I think the same thing is for equality. Like I technically don't need t itself to be ec here. So we convert this to manual. This does not need here. And then we have the same thing here for partial equality. Is this customizable in Rust? I don't think it is. So I actually need to have my manual implementation here. So the implementation is literally the same. The only difference is that this does not require partial equality on the argument, but the implementation is literally the same. Trade bound, maybe var inferable is not satisfied. Subset cache t is inferable. Maybe var should be inferable. Wait, should it be inferable? No. I think what I need is this should be a subset cache key of with maybe subset cache key maybe inside of here. We do with same maybe var t. How about that? Trade bound t inferable is not Yeah, we just do inferable, not same. Sure. So maybe like I can actually put the inferable thing, like the same trait inside of the inferable trait. But this is kind of a derivable, while inferable trait it is not really. Cannot borrow data in a reference is mutable. Signature bias T subset cache call site. Here's the call site. I don't think I need. I mean T here is the same T as basically my thing that I'm inferring. Cannot borrow data in a reference as mutable. Is this subset cache key? Oh, because this gives me mutable. Yeah. I want this to be mutable. Yeah, sure. Diagnostic mutable key. Wait, what is this? Clippy mutable key type. What is this? Something about something makes Clippy. Said here, even though my quote compiles. I still overflowed the stack, by the way. Oh, because I insert, but I didn't check, right? Insertion is returning Boolean. So it returns whether the value was newly inserted, right? So if this was not newly inserted, this means that I have already done this before and I don't need to do anything. So I just return OK here. There you go. This is my caching. So maybe this should work now. Okay, so now I have not yet implemented in lib221. Inferred. Okay, yeah. So inferred. Inferred is a result T, right? Okay, now yeah, this is interesting. Now, how do I get the actual inferred value? So we know the lower bounds and the upper bounds, right? So this is where the final step of the algorithm, the inference, I think, has already worked. So what we need is to figure out what the value actually is based on its lower bounds and upper bounds. So I think that we, like over here, we should do the lower bounds. This is where, like, so they were talking in the in this paper about the polarity, right? So we have polar variable, positive, negative. I don't know if they actually like the coalescing algorithm, right? This is what we want. So in order to produce the actual type values from the internal representation, right? This means that producing the type that has been inferred, actually, right? Yes. So when something has actually been inferred, we do type coalescing. The goal is to replace the positive occurrences of type variables with a union of their lower bounds and their negative occurrences with an intersection of the upper bounds. When do they introduce the like this notion of positivity, though? I have no idea. But what it means, that's literally what it means. Positive occurrences is a union of the lower bounds, and negative is the intersection of the upper bounds. So, like, do we want the lower bound or the upper bound of the variable? Whether the variable itself Like, do I actually ever get inferred values? This is only for showing, right? The type, user-facing type representation. Mm -hmm. Bum, ba-da-bum, ba-da-bum, bum, bum. What I can do though is I can check that a specific thing. So instead of like trying to get the inferred value, I can try checking that a specific thing is within bounds. Can I just check? My citing sources forecast. How do you do? Like this? I don't know. It's not like exactly the thing, but sure. Well, I mean, maybe this is the page that I should do instead. Right? Just make a bibliography in the README. This is basically like the only one. In the README, okay. I don't know. What do you want me to do this here? Bibliography? Like this? Make a reference page on the website? Oh, on the website instead? I don't know. I'll leave it here for now. So the important papers, I guess. There are two important papers. Maybe this one. So far looks okay. Might be changing something though. And then the other important paper is the ghost cell, I guess. We can also reference that. What about Pret Parser and Hilda Milner? I'm not sure if my parser is Pret Parsers exactly. Hilda Milner, I wasn't really like reading things though. On Hilda Milner, I was just implementing it. The Wikipedia page was too difficult for me to understand, but I think I implemented the Hilda Milner. Bibliographies and citations. Yeah. Output bibliography. so that it looks like this. But this is when you actually reference something, like, so you are supposed to reference something when you write something. So if I write a paper, then I would be referencing that, right? But I'm not writing a paper. Pret parser, sure. I mean, pret parser. I don't think I actually read about the pret parser, right? Or did I? Maybe like, I mean, kind of, it's kind of based on this, but it's not like exactly. Pret parser. Just like, like these two are kind of important. Go cell is probably even like the most important here. Yeah. Not sure. Let's have the Pret parser and Hindley-Milner. I'm not even sure what, like, for the Hindley-Milner type system, I don't even know what to reference. What did I read? I literally read nothing. I think the only thing that I read was this type inference in Rust. Like this page. It doesn't like show you how it's implemented, but it's showing you the interface that you're supposed to implement, I guess. Sure, let's have this. It's just type inference in Rust. Downtown. I'll keep it there for now. Maybe we can find a better spot. Okay. So we are failing the test because it's not implemented. So here's what's the problem, right? I'm trying to see that A has been inferred as an actual int n32, but that was not actually done, right? What was done is I have calculated the constraints of this variable. Like, so like when we ask for the inferred value, we can infer the like the lower bound or the upper bound, basically, right? No client attached. Why is there no client attached? Hello? Stupid Rust analyzer. Let me close this. Save changes, yes. So inferred should have the polarity inside, right? Let's just have inferred of polarity, self polarity, polarity, result t. So the inferred would be inferred of positive polarity, right? Is that like I think instead of polarity, I would want to like specify the bound, you know? Like, why do they call it polarity? It's weird to me. Let's just say that we want the lower bound or the upper bound. Minimum bound. Lower or upper. I don't know, maybe there is a reason they call it polarity, but whatever. So by default, I think I want the lower bound. Third bound. Okay. So what I want to do here is I want to do data is self data log, right? So inside the data, we have a bunch of lower bounds and we have a bunch of upper bounds. So I want either the intersection or union of those, right? Yeah. Yeah. So let's... no. All right. The so I'll go into match bound here. If it's a lower bound, then I need to find the union. So this should not even be like T, right? Or like it should be... Yeah, I guess this should return option, because potentially there is no bounds. Which means nothing has been inferred, right? Yeah. So I think we do self dot, I mean data dot lower bounds iterate fold. Not fold, reduce. I think. Reduce. These are maybe variables. Reduce using the union. Maybe var union, right? And this is data upper bounds iterate reduce using maybe var intersect. What does a reduce do? It returns an option. Okay. Okay. But if the bounds are only the variables, then it doesn't matter, right? Like what I want is only to have the bounds here of the actual values. Is that it? Hold on a second. Let me take a look at what they did. Type coalescing. Yeah, recursive. So for the recursion. I don't... Yeah, let's not care about the recursion yet. On types full left. Merger is either union or intersection. Bounds, we map. We do every bound. This is what is currently in process. I see, I understand, for the recursion. To figure out the types. I see. Okay. Mm -hmm. Mm -hmm. Let's think about this. When I have this inference in this test specifically for the integers, I specify that I say that A is the same as B is the same as C, right? And let's just, like, even if I say just A is the same as B, what ends up happening is that I say that A is a subtype of B is a subtype of A. Then I say that they are equal to int. I'm just having a maybe bar. How about so lower bounds? Okay. Hold on. I think I want to do this. Maybe var self clone inferred bound. Let's do that. Let's do this inside of the maybe var. Function inferred bound. This should return t, right? Self So if it's a value, yeah, so if this is a value, then I just return value, right? And then if it's a variable, then I do this. So lower bounds, iterate. Do we have try map? Data. Variable data look. So we have try. There's a try fold. There's no try map, but there is a try fold. Initial one is going to be none. Function is going to be so we have accumulator and item. And item. I'm going to say match accumulator, sum accumulator, and then we do t union. So like union and intersection should be operations supported on the inferable type itself, I think. Maybe accumulator and item, where item would be what is trifold anyway? A result is try, yes. This is not nightly, right? It's stable, nice. T union accumulator and item inferred bound. If it's none, then some item. Item is converted like this. So for the upper bound, it's the same, but I iterate over the upper bounds. I get the inferred bound, and then I do the intersection. So that's it. That's all I need to do, right? So the result, in this case, is going to be a result option. So over here we do question mark, over here we do question mark. Now this is an option. The only reason it is option... Wait, it is option result? Wait, what is trifold? Returns the result option. Result option result. No. We should return R, which is the result. Accumulator is option result, because this should be question mark. Item inferred bound, question mark. Like this. That's why. Right, so now result should be just option T. There you go. So then I return result. Okay. Match result. Some result. None. Bail. Not inferred. So like there is nothing to infer there, I guess. So now all we need is the union and intersect, lower upper bound. This thing should be copy clone hash. Sure. So now the inferable thing should specify how to do the union. A self and B self. Like this, right? I can probably do like references here. I don't know. And intersect A self B self B result self. Maybe instead of union and intersect, it should be like called common subset and common superset. And union. Let's take it by ownership here. I think it's fine. Not sure. Okay, so now I want over here expected T found found option T. Sum. Should be okay. Should be just okay sum. Type annotations needed. This IRE report, I guess. All right. So now I just need to implement the inferable variable. Wait, what? Function intersect. To do. I don't think this is actually doable here. Maybe this should be in a different trait. Okay, so let's say let's take this example, right? When I want to union, so like what is the common value between two integers? Well, it's really easy, right? First of all, both of the integers must be same, so we can only unionize the same things, right? If if a0 is not equal to b0, then prevail a not equal to b, right? Otherwise we just return okay a. So it's the same as in when I infer that this is a subset. Let's do debug here. Okay, and then when I do the intersect, it's I have the same thing. All right. Yes, it's the same thing. I think I do want to do this. Let's change this from union to be common. So when we do a union, this is a superset, right? And this is subset. Common subset, intersect. I mean, this is literally intersect and union. Yeah, whatever. Let's call this like that. Downtown. Hello? Okay, and now in this thing, so for the integers that are less than a number, this is a little bit more interesting, right? Because for, like, if I want to have a union of a type which is an integer less than a, and then an integer less than b, right? So self a and self b, right? This should always return okay, because the union, which can is something that can handle both of these, so the union is the maximum, right? So std cmp max of a and b, self, right? And then intersection is the minimum. The test passed. Wait, hold on. The test has passed. The test has passed, guys. So this test has passed. Look at this. We say that we have a variable which is integer. The inferred variable turned out to be 1, 2, 3 for all of these 3 variables, even though I set only one of them to be 1, 2, 3. Let's not ignore this test. I think this is actually working now. It's working too. Look over here. Maybe like this should be a better test though. Let's say that this is a better test. Let's say that let's also have d maybe. To have a variable called d. So a, b, and c, they are the same right now, right? But we want to have actual subtypes, right? We want to have actual subtypes. So I think I want to say that a is a subset of subset, superset of b. B is a superset of C. Let's also say that A is superset of D. And D is int less than 456. Right? Okay, there you go. So now we panicked. Because line 77 over here. So here you go, right? This is basically the so this would be the equivalent of me writing code like this, right? Let d be the type int less than 456. Then we say C is int which is less than 1 to 3, right? And then I say something like let B equal C, let A equal B, and A equal D. So right, when I do this code, since I need to assign the value of B to the value of A, right? This means that B is a subset of A, which means that A is a superset of B, right? Because only then we can assign B to A, right? What's new? Not inferred? What? What's new is that we have subtypes now. So this is the example over here. We do this from like bottom up though, I guess. Was new not inferred? What do you mean new not inferred? This is creating a new not inferred value, literally. This is something that I want to infer, right? So this is the code that I'm trying to compile. When I'm trying to compile this code, I have some type annotations. All right, this over here says D is an int that is less than 456. So I say that C and D should be inferred as specific things. Integer that is less than like 456 or 123, right? Then when I see this in code where like B is equal to C, this actually means since C should be assignable to B, this means that type of C is subset of type of B, right? So this is the thing that the compiler is supposed to like specify by calling into the inference engine, calling these methods, right? So this is the equivalent of what the compiler is going to do when it sees this code, right? So since basically now this means that A should be like, according to this code, A should be both an integer that is less than 123 and an integer that is less than 456. Since it should be able to handle both of these cases, the only type, the minimum type that can handle both of these cases is an integer that is less than 456, right? So this means that inferred type of A is actually an integer that is less than 456. But the type of B, because B is only coming from C, B is still 123. C is still 123. And D is just like as we said, it is 456. So this is the actual test now, right? There you go, and it passes. You must save us, make us the language that solves graphics. Okay. I need to like figure out graphics first though. Oh, Ray March. I think this is good. This is a like. Can we have some more some more complicated test? We can have something else. Let's say let's have another test, like something similar to TypeScript. How about this? Something similar to TypeScript. So we have a type which is like type, and type is basically a hash set of like some types, you know. How about this? std collections hash set of strings. Same. So I need to, yeah, so like, yeah, I guess I just want to implement the same for a hash set of same things. Let's do this. Inferred bound. Bound is more public. Yeah, this should be public, sure. Implement same for. Yeah, so I want to implement same for a string, obviously, right? And then I want to implement t same for hash set of t's is same is I think this should not be that. I think this should be public with same t. Yeah. Let's, instead of doing that, use here hash set with same string. How about that? With same does implement debug. You have at least n trait, but you can't make it understand that n is at least n. This sort of stuff in Rust doesn't really work. It will only work for non-generic n. Well, Rust doesn't have subtypes really, right? I mean, we have traits. At least n. Wait, so you use the at least n in your stuff? Why do you need it? For graphics? You need something that is at least something? Let's not ignore the test. So this would be a test like type set. Let's do that. The trait bound hash set same is not specified. Oh wait. No. We do with same. Like that. There we go, Mr. Halsey. Yo, hello. Thank you for the raid. A raid and run. Thanks and bye. All right, I'm going to end the stream soon too, but for the raiders, we are finishing implementing inference with subtyping for my custom programming language. I'm writing a test right now, which is going to be something similar to like TypeScript, where if I like assign to a variable a string, and then later I assign to the same variable like an integer, then the type of that variable should be string or integer. So like I want to test that this works. Why do you add subtyping? Where do you plan to use it? Rust has subtyping for lifetimes. We will have subtyping for the effects. But I probably will want, like, subtyping is a nice thing to have, I think. But it's mostly for the effects, for the contexts. Because like you know, when you have a function foo and it calls function A and it calls function B, that means that the effects that foo has is the combined effects of A and B, right? So the effects of A is a subtype of the effects of foo. That's what it means, right? We have subtyping actually here. Like, you can take a look at the Haskell's effectful library. I don't know if you were here when I was writing this, but when you write effectful in Haskell, you literally say that the list of effects contains this thing. Like, it's like very similar to like subtyping there. Where's the example? I don't remember where how to read these documentations. But like, you specify literally the that like there's subtypes there. Lately I've been changing debug being first derive, started ordering them exclusively alphabetically. Maybe there is a settings for the Rust formatter that can do that for you. I'm not sure. Operation cannot be done for this. Okay, partial ACK with same. I mean, I can do partial ACK, sure. Let's have that. Oh, there's a conflicting implementation. Wait, binary operation equals cannot be applied to the with same. Hold on. Oh, because that thing must be same. And if it's not same, then I cannot do that. I see. Let's just not derive this. Same. Wait, what is this with? Oh wait, with same is like doing the equality. Like I want to do it with the other way around though. Okay, hold on. I want to basically implement same for type. Is same is self 0 is equal to other 0, and hash would be std hash hash self 0 state. Let's just do that. What is this? Trade bound collection. Oh, a hash set is not hashable. That's right. I need this to be a binary tree set. Okay, so we do inferable for the type, right? So here we go. Since this is literally now a set, if I want to infer something to be a subset of the other thing, then I just need to check that this is literally a subset, right? Less than or equal, I think, is incorrect for the binary tree sets. And say like subset is subset. There you go. Is subset. Is subset of other 0. So if it's not, I mean, if it is subset, then it's totally fine. But if it's not, then with a fail checked, right? And then we want to figure out the union. The union of things is literally just self a dot union visits all elements representing the union. So I just do like union b collect. Is that what I do? A value of type iterate set going to be built from an iterator over elements of type string. Cloned collect. Okay, and then intersect would be okay, self a intersection with b cloned collect. Right? Like this. Okay, so let's say that once again we're writing some TypeScript code, right? Where we say let x be hello, right? Which is a string, right? And then I say x is equal to 1, 2, 3, which is a number, right? Which means that type of x should be string or number, right? That's what we want to see. So we want x be type variable new not inferred. Variable of type. So we say x infer as a superset of type singleton string. and singleton number. Assert equals x inferred via type from iter string number, right? Something like that. Impl type function from iter impl into iterator. Item is string, whatever. Self type iter into iter. S2 owned. This should work. Equals doesn't work. Yeah, let's just derive partial x. That's fine. Anonymous is unstable. Of course it is. I think this can this be just like as ref stir, so that I can do this as ref owned. Okay, and this works, right? This test works. This test is super small though. Like, I mean, I guess in order to test if this works for like bigger programs, we just need to actually write those programs. So this inference now is its own standalone crate. And with this test, it is shown how to implement inference for your own things, I guess. So I don't know about these to do's. And how to do proper tests here. So like test what that they were doing. Down. The code used for generating and testing these expressions can be found online in ML subcompare. You know, I think that I should do this. I should use the tests that they provide there. So basically, they have a lot of expressions that we know what they should be inferred as, right? ML subcompare branch of the repository. All right. Or we can skip the test and try using this. Okay, but anyway, that's not going to happen today. I'm going to be done. I think this is nice. If it's working or not, who knows? But the simple tests, they pass. New inference with subtyping. Smile. Yeah, I think that's going to be it for me. And to go. Thank you for watching. And thank you for the follows. Hello, Mr. Twitch. Can you open, please? Right. No one writing Rust. Let's go to this guy who's writing Zig.
Time zone identifier.
Bye. See you next time.
There we go. So here's how we do it.